All right, can everybody see me out there? Virtual world. Thank you for that, Krista. And I see somebody you kind of monitoring the chat there. So, without further ado, welcome, welcome, welcome. Glad everybody made it. Let's give everybody your own selves a round of applause. Everybody made it here today. Everybody made it safe. There was a tree that fell on the campus, and all kind of weather alerts from NOAA and all of that. But everybody said so. Thank you all for making that happen safely. I'm Randy Rowell. I'm the program coordinator, and I'll introduce Bart.
Yeah, Bart Merrick, I was just day off. I'm just kind of helping support the intern fellowship program throughout the summer.
All right. Okay. So without further ado, just want to say, it's been a great journey. I know you all been working on your projects all summer. And this is kind of the hurrah of your summer. And I'm just really proud of each and every one of you all for taking on the challenge, for applying, for working with your mentor, and just essentially having a level of stewardship amongst yourselves that requires you to both care about the environment and just yourself and your career and things like that. Me myself, I got into this career mainly because I wanted to find something that was fulfilling, that allowed me to also tap into the environment and also young adults and youth, and really seeing how I can be of service in that regard. So, and so that's pretty much the gist of that. And I want to introduce Denise as well. She's the executive director of CRC. You want to just stand up and say hello?
Because there's lots of visitors here. I know the others kind of know it, but I'm an ecologist, so I'd like to know about where I am. So I thought I'd just tell you about the campus. You're on the campus of the Smithsonian Environmental Research Center, which is almost 50 years old. It was begun by the queens of a farm. And what makes it really special is it's 2,650 acres. It's got 15 miles of protected shoreline, which in the Chesapeake Bay region is quite astounding, actually. And it's really the home of, I'll tell you, some major pieces of research. So,
could you come up a little closer to the podium? So
Come on down.
I like to have a little bit of fun when I have that. It's not going to be very stiff in here.
yeah. So, at any rate, it's a large campus, and they really focus on coastal issues. 70% of the global population lives on the coast, so what they do here has a lot of impact globally. I'm just going to tell you about a couple things that go on here scientifically. There's 180 people that work here. So that huge science building, it's called the Matthias Building, was actually the first platinum LEED laboratory in the country. Which is pretty cool. So if you get a chance and it's not raining, you might want to walk over there and look through it. But 180 scientists, researchers, technicians, students work here. They're also out in the field, anywhere from the Arctic to Belize and Panama. So they're kind of sprinkled across all these field sites. One of the really interesting things to know is that the longest running CO2 enrichment study in the globe is here. It was started almost 50 years ago in a marsh. It's called G-Crew, and it's really astounding if you look at the knowledge that has come out of there. Maybe one of the other interesting things is when they acquired part of the original plantation, so it's also got a little bit of a history it's trying to grapple with. It has a really big citizen science effort. So the archaeology that's done on site is completely a citizen science effort, and they run a lot of other citizen science programs. Another thing that's pretty cool is that every ship that enters a port in the United States has to test its ballast water for invasive species to know how those species are sort of traveling around the world's oceans. That database is here. Every ship that enters any port sends a sample of the ballast water, and that information is all kept here. So if you go over to the Mathias building, you sort of wander the halls, you'll see posters that talk about all the kind of pieces of science that gets done here. So it's a really interesting part of the Smithsonian, and it's just a really cool place to work and read. Anyway, thought you might like to know where you're sitting. There's a word of applause for that.
You do right, man.
Yeah. All right. So I have the role of timekeeper here today, and I also want to just cover some basic logistics so that we're all on the same page. Because one of the awesome things about this program is that we do have quite a few people that were with us during the summer that are doing some amazing work. But to be able to fit a quick synopsis of that work and some of the learning from it into a day is a challenge. And so what we've done is we structured as everybody that's going to be presenting really has 15 minutes total in their time. And so what I'm going to do is I'm going to have a timer up on my laptop for 10 minutes. So you'll be able to see that and track that to know just kind of where you are within that timing. And then we're going to open it up to questions. And when it's about 2 minutes left, I'm going to give the 2-minute warning on my fingers here, and then I'll stand up when we're done if I need to just kind of cancel this out. And we have to be pretty strict at that. So I apologize if I cut anybody off that is speaking in the middle of stuff, or if I don't get to all the questions. It's just kind of the nature of the beast here today. But that doesn't mean that we don't encourage questions. We absolutely do. And we encourage like as much dialogue as possible within the reasons of the timing we have. So we are running all the slides off of Google, and a couple questions have come up around that. And just to go over quickly logistically, like being able to kind of look at our notes and reflect on that stuff, there are some tools that are built into being able to do that. So we have a folder of presentation slides, and I'll drag that over here just so you can see that. And let's say Bryn's up here first, but just how to get it so that you can see your slides. And when you go to slideshow, and Brandy might be setting this up for us, but if you click on that presenter view, your notes will come up, and you can just drag them back to the main screen that I'm looking at right here. And you'll have your notes in front of you. The little buttons will click so you can get to your slides, and you should be in good shape. Questions on that logistics?
Part for just audio for the people online. It's going to be important to stand at the podium because that laptop is what is broadcasting audio. And if you do take a question, if you could repeat the question so that the folks online have context for your response, that would be helpful.
Awesome. Thank you, Melissa. Any other logistics that I'm forgetting out there?
You could tell them who you are.
Oh, yeah. I'm Bart Merrick. So for people on the camera, yeah, Bart Merrick. I work for the NOAA Chesapeake Bay office and help to coordinate internship and fellowship programs like for the NOAA component of this. And so we're really excited, again, like to see the product of everybody's work here today and actually just really kind of reassemble here at the end of the program to hear from each other, to kind of reconnect with each other on what is the last day of the program. So without further ado, I'm going to hand it back to Randy, I think, to introduce Mariah.
And a big part of this program and what kind of separates us from other fellowship or internship programs, we really want to try to support you all throughout the academic school year. So when you go back to your home institutions, just be real mindful of trying to check in, and we'll be checking in still with you. Maybe try to find a mentor at your home college and connect me with that home mentor. And so throughout the school year, you can continue to access your professional development funds and different things like that so that you're able to continue on throughout the school year. And we really encourage returning fellows. So this year we have Emma, who's a returner. You just want to raise your hand. And Emma has been twice. And she's also traveled to some conferences on the West Coast. And so you'll be hearing more about her later, but she's an example of that. So another part of our program is really putting you all in front of people that you all can relate to, people that are, from your work of life, and also people that are kind of young like you all, versus a bunch of old people like me. But So without further ado, I just want to introduce Mariah Davis. She's the new environmental justice officer for Maryland Department of Natural Resources. And we've known each other for a long time. Well, long time, it seems. But, you know, I'm just really proud of her growth in her career and kind of where things have led to one stepping stone to another. So without further ado, I'm going to call her out. Thank you. Oh, oh, that is the right one. The C string.
Mhm.
Yeah.
Is it streaming to the people online too?
You wanna share it. Is that good?
Can
Can
the
you all
people
see that
online-
on?
You'll need to share the
Okay.
screen.
Sorry.
Does that work?
All right, cool. All right, well, good morning, everyone. Thank you, Randy, for that very kind introduction. I'm not as tall as Randy, so I'm gonna kind of stand to the side. I'm not as tall as Randy. Okay, okay, I'll be over here. But anywho, I'm Mariah Davis, and I'm going to talk to you a little bit today. I'm going to go kind of fast in my slides, but I'm going to hang around for some of your presentations if you have any questions. But I'm going to talk to you a little bit today about who I am, my career path, what I do in my job, and leave you with some resources for your career. So this is just a little bit about me and my career path in logos. I'm from Virginia originally, so I went to Virginia Commonwealth University. I studied environmental studies. I thought I wanted to be a doctor and found I was just really passionate about the environment and the Chesapeake Bay. I grew up in the Virginia Beach area. My parents were in the military, so I got to travel quite a bit and just spent a lot of time outside. So I got my degree in environmental studies and I minored in chemistry. And then I had to find a job. So I started talking with my professors. They told me about a group called the Alliance for the Chesapeake Bay, and I started volunteering there. And I had a lot of different jobs just to try and like break into this field. I didn't have a program like C-Stream. So it was really just me relying on my network. I definitely encourage you all to, stay in contact with us, stay in contact with the people that you've met, your mentors. We all know each other. And so it's a small and very, intimate and passionate community of people. And it's really, helped me and get to where I am today. I started working at a group called the Blue Sky Fund. That was my first kind of exposure to mentorship and really the importance of having representation in this field. We took kids outside, Black and brown kids, and exposed them to nature. That was a really fun job. And then I started working for Virginia Conservation Network in Virginia. And that's where I really got my exposure to doing policy and advocacy work. So I was doing a lot of work in the state legislature and at the federal level. So talking with members of Congress and different stakeholders about climate and water and all kinds of different issues. And I've gotten to do some leadership programs. So I did a leadership program with the Congressional Black Caucus Foundation. They have a political leadership program for people who are interested in doing campaigns or running for office. So I definitely encourage you all to look for resources for your own professional development as you continue throughout your career journey. Those are things that have helped me tremendously. I'll talk a little bit about Annapolis Pride in a couple of slides, but after working in Virginia, I moved to Maryland. I live in Annapolis, and I started working with a group called the Choose Clean Water Coalition. It's a coalition of over about 300 nonprofits, a lot of the groups that are here today, and also probably some groups you've gotten to work with too in your experience with this program. But it's a program of National Wildlife Federation. So I was also working at National Wildlife Federation. I got my master's. I took time to wait and to get my master's, and I went to University of Maryland and got my master's in public management in the School of Public Policy. And then I started working at Maryland DNR, so the Department of Natural Resources, and I've been here for about 6 months. So I have about 10 years of professional experience, mostly in nonprofit and now working for the state, working in state government. I'm not going to go through this whole list of my skills and expertise. It's mostly just to help, inspire you and to really think about what skills that you have and, what you can bring to your job. I was also a waitress. I waited tables all throughout college and, got event planning experience and, talked about that in my job interview and being able to manage a large workload. So those were, some transferable skills that I have that I want to just encourage you all to really think about as you're searching for jobs. So this is a little bit more about me in photos. I talked about how I love being outside. So there's some pictures of that. When I first moved to Annapolis, there wasn't a lot of LGBTQ representation. So my friends and I created a group called Annapolis Pride, and we planned the Pride Parade every year. We had 11,000 people come to the last Pride Parade, and I was very fortunate and got to march with the governor this year. That photo is from a demonstration we did with Black Lives Matter after George Floyd passed away. This top right picture, I love this picture. This is a really cool experience I got to do in my role at DNR. We have a bear program, and it's for conservation, and we knew that there was a mom cub who had babies, so we tracked her, and mostly we're there to help keep the babies warm. Mom was asleep, but we, made sure the babies were okay. But yeah, I've just gotten to do some really cool experience. I'm not going to talk too much about the people in suits, but these are some members of Congress that I have great relationships with, and they've been mentors for me over the years as well. So a little bit about my current role and what I do. It's a new position. It's a political appointment. And so when Governor Westmore was elected, justice is really important to him. So he hired a lot of people who are doing justice type of work in these state agencies. So there's other people in similar roles to me, but at different agencies like Department of Health and Housing and Planning and Maryland Department of the Environment. So I was hired to be an advisor to the Secretary of Natural Resources. His name is Josh Kurtz. So I work with him and I work on DNR's executive leadership team. So I help to support environmental justice efforts throughout DNR. DNR has never had anyone with a sole role to work and do environmental justice. So a lot of what I do internally is really trying to educate the staff, streamline our programs, also making sure that we're working with communities and making sure that they're getting access to the funding that we provide. We're probably one of the largest, if not the largest, environmental grant makers in the state. So it's really important that we have those relationships, but also that we're working internally to be able to have the skills and the resources and the time to reach communities where they are. And that's a picture. That's my second week in my job. I got to talk with Governor Moore about the importance of the Bay and why environmental justice is also just really important to that movement. I kind of skipped over that, but Secretary Kurtz, so Governor Moore is the chair of the Chesapeake Executive Council, so he has a leadership role. He is the leader and really driving a lot of, what's going to be next for the Chesapeake Bay. What will, maybe a new agreement sort of look like. And so my boss, Josh, also has a huge leadership role in that. So I'm happy to continue and be a part of that work. I'm not going to go through all these definitions with you, but as the environmental justice officer, I have to talk to you about what environmental justice is. So racism exists which is why we have environmental injustices. And basically, people are being poisoned by a lot of our environmental decision making. When I think about environmental justice in Maryland, I really think about the people in Baltimore, around Curtis Bay area, who are living and breathing a lot of air pollution, and who are just literally being, dumped on by a lot of these, decision makings. But because of, racism, we have environmental racism, and people of color, low income people, people who have immigrated here, they are at a disproportional, rate being impacted by environmental harms, which I will talk about in the next couple of slides. So as y'all are continuing and starting your career in this movement, I think it's really important for you all to educate yourself on what environmental justice is. When I was in college, they didn't talk about environmental justice when I got my environmental studies degree. I didn't really start learning about it until I started working in the field. But it is a part of the civil rights movement. And so one of the last things that Dr. Martin Luther King did was fight for environmental justice. Just a few months before he was, killed, he, started talking about environmental justice. And these are just some of the events that have occurred and have resulted in this, global movement in environmental justice. But it really started with people in their own communities organizing, getting together. There were, landfills, and there was a community of folks in the South who found that, these landfills were being placed in Black and brown communities and people who were low income, and that was being done on purpose. It's a very intentional thing, and it continues to happen today. And so the guy on the left, that's Dr. Robert Bullard. He's considered to be the father of environmental justice. So if you're interested in educating yourself, I definitely encourage you to look him up. I'm not going to go through all of these events, but what I really want to touch on is that a lot of this started with community organizing and people just really speaking out. So it's important that y'all are paying attention to what's going on in your communities. Fast forward to present day, it took a long time, but now, we have some things in law. It's not perfect to help protect communities from environmental justice, but it's really important that the state and organizations continue, to hire people who are really up to speed and have expertise in EJ issues. I'm not going to go through all these, but when I think about environmental justice and those impacts that I see today, flooding, we're going to see a lot of that today. And, throughout the week, when I think too, just about urban communities, those communities who don't have a lot of, tree canopy. When our parks were created, they were founded in racism. I definitely encourage you to look that up. But a lot of the, parks and a lot of the green spaces that we have were created and designed to separate people and really disenfranchise people, which means that people, economically also don't have the same opportunities to really get ahead. So it's very much so embedded, into our society and to our society. But, in photos, these are just the things that I think about when I think about environmental injustices. Your zip code very much so determines your life expectancy. This is a public health, issue. So I talked a little bit about the connection to green spaces, but communities who don't have access to those green spaces aren't expected to live as long as people who do have access to green spaces. And that also goes back to health, but it also goes back to, emergency responses, like when is the ambulance going to get to my house? It's all very much so related. I'm not going to go into these statistics, but these are some statistics I just wanted to share with you. 63%, people of color are exposed to up to 63% more of pollution than white counterparts who are exposed to 17% less. 68% of Black people live within 30 miles of a coal-fired power plant. Black people are 75% more likely to live near a hazardous waste facility. And in 46 states, that's a lot. People of color live within more air pollution than white people. So you can see that it's not a coincidence. It's very much so, deliberate and intentional, and connects back, just to years and years and years of racism. These facts came from climaterealityproject.org if you're interested in seeing more. But like I said, there's a lot of great research and things out there if you'd like to just learn more. I want to talk a little bit about the principles of environmental justice. What we're really bad about in government and as an environmental community is going to places and into communities and telling them what they need, which is not what we should be doing. We should really be taking the time to listen to people and get an understanding, because they're the experts. They live and breathe that community. So it's important that we're being really inclusive when it comes to decision making and taking their opinions into serious considerations when we're making decisions and passing legislation. So that's really what that bottom up approach means, and really listening to people and letting them speak for themselves. But anytime you're doing this work, it's important to live and breathe by these principles. These are the James principles of democratic organizing. There's also the 17 principles of environmental justice. If you're interested in starting a career or getting involved in this work, I think it's really important that you educate yourself on these principles, because it's really how you should be approaching the work. Back to DNR. I didn't talk too much about what DNR does, but as the Department of Natural Resources, we manage all the state parks. We have almost 80 state parks in the state. We manage all the state forests. I talked a bit about the bay and water quality. So there's a lot of different programming and things that we do. This is just, I think, a small snapshot of the work that we're doing related to environmental justice. I won't get into all of it, but I am very proud. I was very proud to see that all of this really great work was already taking place before I got to DNR. So I'm very happy to continue supporting work like this and being able to work with great partners who are here in the room. If you ever want to start a career doing environmental justice work, I encourage it. I love my job. I love what I get to do. There's all kinds of things that you can do by having this expertise. You can start a business. You can start a nonprofit. You can work in positions that are doing environmental justice work in environmental nonprofits, or you could be the director of one. You can start your own thing. There's a lot of environmental justice lawyers. We need more of them. If you're ever considering a career in law, that expertise is really helpful. You can do policy, which is what I do. I didn't put this up here, but you can teach. You could be a professor and teach this work. GIS and mapping. This is really, really, really important. This is not an area that I have a lot of skills, so I rely on my colleagues. But this is really important if you're ever interested in mapping from an environmental perspective. Having people doing EJ work is really important too. How do you get started? There's more and more universities that have degrees and concentrations in environmental justice, which wasn't something that I had access to. But there's internships, volunteering. Volunteering is probably one of the easiest ways to get involved. Get out the vote efforts, get involved, start doing campaign work, start getting involved in your electoral process so you can really understand the process of decision making. Shadow someone's coming to shadow me next week, and just to learn more about what I do on a day-to-day. There's lots of listservs. There's a ton of information on social media. Back to your network, add me on LinkedIn, talk to Randy, stay connected with people, continue your relationships with mentors, find more mentors, keep your resume updated. I'm not going to go through all these resources, but you're welcome to take a picture.
Slides, right?
Yeah, you'll have the slides. A couple of things I want to point out to you is that the governor has a couple of different summer internship programs for recent college graduates. So they're up here. You can also consider a job at Maryland DNR. I definitely welcome you. At the very bottom is a job finder called Chesapeake Network. So if you're looking to kind of step into your career, it's a really great resource. The program above that is called YPC, Young Professionals of Color Mentorship Program. If you want more mentoring and you're a person of color, I definitely encourage you to take a look at that program. The Alliance for the Chesapeake Bay, they're hosting an HBCU summit that's coming up this summer. It'll be in September. I'll be there talking, and yeah, these are just all really great resources. But this is my, information. If you want to stay in contact with me, you're welcome to add me on LinkedIn. And yeah, that's pretty much all that I had for you. It was a lot of slides, a lot of information. I'm not sure if there is time for questions because I also want to hear about all of the work that you've been doing. So yeah, thank you.
So much. Does anyone? Thank you.
Yeah.
Anyone have anything?
We're pretty close. We're at time.
Yeah.
Sorry. But
Bart says no questions. It's okay.
are you going to be through lunch and stuff like that too?
I'll be here right up until next hour. I'll be here.
And okay, so first up we have Henry. Let's give it up for Henry. Which one of these is yours?
Should be Summer of a COL Intern. Right there. And then is there notes that I can look at or?
Yeah.
Can I see some?
Yeah.
Where'd it go?
No, cursor is over there.
Aha.
I like the button.
Oh, thank you.
Trying to pull his notes up.
Oh.
Okay.
No, I'm here.
Oh, you got it. Okay.
So, right. And then to. No. Yeah, we'll just deal with that. I think so. Just want to pull up. Yeah, there we go.
All right. Great.
All right.
So, introduce to you all Henry.
Hello, welcome to the final symposium. My name is Henry Sage, and I'll be going through my summer as the Cooperative Oxford Labs Marine Biology intern. A little bit about me, I'm a rising senior at the University of Miami studying marine biology and ecology with a minor in marine affairs. And I can tell you that I've used every aspect of both my major and minor at the Cooperative Oxford Lab. To kind of paint a picture of my summer, I got to go over what the Cooperative Oxford Lab is. It is a cooperative lab between the Department of Natural Resources of Maryland, the Coast Guard, and NOAA. They all work in the same lab, not so much the Coast Guard, but definitely DNR and NOAA work together in the same spaces and have to share resources in that way. I worked with a lot of different people and a lot of ongoing research at the lab. I mean, I'm working in a pilot study with the Strand Project, historical oyster sites that I'm looking at for DNR fish inspections throughout the summer, sampling at Poplar Island, which my fellow intern Oliver will go over as well. And I also got to be involved in some pillar coral permitting, which I did not think I was going to get into as a marine biology intern. I will say there is some pictures of deceased organisms. I worked with some deceased macrofauna with the stranding team. So there is a slide with some pictures of dead animals. If you don't want to look at that, there will be a little warning beforehand. This icon will be in the bottom left-hand corner. One of the bigger projects that I worked on was a pilot study called the Strand Project. The Strand is a beach in Oxford, Maryland, which has been enhanced to have living breakthroughs as well as living shoreline elements. The goal of this project was to compare fish communities between living shorelines and then traditional gray infrastructure. So in the top right, you can see that's the living breakthrough with the living shoreline elements. We sampled here the yacht club there in Oxford, which acted as our gray infrastructure, and then some other beaches. We used eel pots, sea bass pots, and these seines, and we counted up the fish that were caught there to compare the fish communities present. And one of the biggest things I learned from this project was things go wrong in science, especially in a pilot study. It was really inspiring to see the team adapt to different challenges. That first day, that terrapin was found in one of the sea bass traps, which is obviously not what we want. We added turtle excluders, we changed soak time, we changed bait types, and I was really able to see, first and foremost, that there's a lot of fine tuning with pilot studies and in marine science in general. And I was able to see that firsthand. The next project that I was able to work on was the Vibrio Ecological Forecasting Project. This had the goal of assessing the presence of two species of Vibrio, Vulnificus and Perihemolyticus. Perihemolyticus usually causes shellfish poisoning if you're eating raw oysters and are feeling sick. That is Perihemolyticus doing its thing. And Vulnificus is infecting cuts. We are seeing the CDC says there's about 80,000 cases a year from these two Vibrios, with 150 to 200 being Vulnificus. They are freely living within the water, and we care about them because they are human pathogens and cause shellfish disease and shellfish poisoning, which is commercially important for oyster growers and as well for medical professionals who are trying to diagnose people with infections if they're in and around the bay. The process for this is we get samples from around the bay. We filter them through little Steravex filters, about 200 milliliters. We freeze, then crack them, get that filter and put it into a power bead tube, which will mechanically and chemically break down that filter to expose the different Vibrios there. And we will use PCR techniques to amplify specifically the Vulnificus or the Perihemolyticus to figure out the concentration of Vibrio that was in the water at that time. And we use that to then validate this model. It has a 6-day hindcast, a 1 day of the today forecast, and then tomorrow's expected Vibrio forecast. So you can see the green would be that there is a lot of Vibrio at that time, and you would want to be careful of eating oysters or recreating in those waters at that time. The next project I got to look at was looking at historical oyster slides. So I got to work with human pathogens. Now I'm working with oyster pathogens here. In the top right, this is MSX, or Haplosporidium nelsoni. In the lower right is Perkinsus marinus, which is dermo. You're actually looking at, this is in the mantle, but the MSX is mostly found within the gills. It looks like the oyster pathologist calls them little blueberry pancakes. But you can see the dark purple are hemocytes, and the little larger circles are the MSX, which these are fatal to oysters. They can cause mortality events, which is, again, economically important for oyster growers, as they can find that their whole stock can be decimated by these two. And this here is the dermo. This lives in the gut, which under a microscope, the intestines look like little threes. So that's really fun. But this is supposed to be very striated columns of cells. And as you can see, it's very globular. And that's because the intestinal lining is being eaten by that dermo. So I looked through historical oyster slides from the early 2000s to look at the presence of MSX and dermo, which the oyster pathologist actually does on a yearly basis for the entirety of the Chesapeake Bay. He looks over 1,500 oysters and produces that in a fall oyster survey. So it's important to look back in time and figure out what MSX and dermo was looking like, not just in Maryland, but across the eastern seaboard. And now we get to the fun stuff. I worked with the marine mammal and sea turtle stranding team. We picked up stranded organisms and deceased macrofauna. Specifically, I got to work with a female loggerhead and a male gray seal. And I'm gonna move on to the next slide. There are pictures of dead animal parts and dead animals. So in the bottom left, you can see me measuring a very small lesion. These are millimeters in diameter. That just goes to show how thorough the stranding experts want to be. They're marking down every lesion, and we are also looking at every organ, which you can see in the middle picture here. Those are its lungs. I did a procedure called bread loafing, which is kind of colloquial, but you are doing cross sections to look inside the tissue, and you can actually see roundworms that were found in the airways, kind of in the left corner of that cutting board. And it was actually pretty cool because there were no conclusive external markings on that seal. So it was very important that we were able to look at the organs to see what could have possibly caused the death of the seal. And then here is the sea turtle. It was pretty obvious how it died. It was a boat strike. You can actually see where the prop entered the body cavity in the GI tract on the left side there. And it looks really gross, but it was seeing these charismatic people really care about what they're doing and caring about our charismatic macrofauna in the Chesapeake Bay was really interesting. And these were some of the highlights of my summer, believe it or not. And all that's to say, I had a really great summer. I got to work with a lot of really cool people. I couldn't even fit them all on this slide. There's Amanda holding up a leatherback sea turtle skull. There's Matt, who was with me measuring it. Jason's holding oysters. I mean, these people are really, really great. They're brilliant, and I had a fantastic summer because of them. I'd like to especially thank the people that I worked with on a day-to-day basis. That would be Ava and Rose on the left side. They were instrumental in making this summer as fun as it could be, and I really want to thank my office mates, if you can call it that. We were in the same room the entire summer. Bria's sick of me opening the door into her chair every day. It's fantastic, but they really made the summer as fun as it could be, and I'd like to thank them. These are my collaborators. I worked with Maryland DNR, NOAA Fisheries, NCOS, and obviously NOAA. And I can take time for questions because I got 1:16 left.
Which project was your favorite?
Ava, cover your ears. It was definitely the Strandings. They're really funny, the people that work there. And I get to say I got to cut open a seal, which is something that I'm sure none of you are able to say. Except not Oliver. He didn't get to do it. Oh, Bria did.
Henry, how can we watch more about DNR?
Sorry?
How can we watch more about marine mammal training programs, DNR, online through a TV show?
Oh, you can go to an episode of Dirty Jobs where the Maryland Marine Mammal Stranding team is the focus of that program.
Great job.
Thank you.
And next up, we have Oliver. Just come on up and introduce yourself. You know how to pull up, you need notes? Huh?
No, I don't have any notes.
You don't, you have
Just
notes?
to pull from the slide? You mean, or
Just
notes? I don't
your
have notes.
slideshow.
Just the slideshow's fine.
Is that cool? Oh,
Fits. Yeah.
So, like all of our others, like I'll remind you, like, we have 10-minute, the timer is a 10-minute timer. We have 15 minutes per person too, so just know you have a little extra time for questions. The timer is like the talk part ends, so questions can start. Just, you know, like, having thank you very much. You guys got it. Because we're Ryan. We appreciate it.
everybody see that?
Is there anything I can do to go to the next slide on this? Or?
Yeah, space bar or the arrow. Okay.
That's good. All right. Good morning, everybody. Thank you for being here. My name is Oliver Soika, and I was the fish ecology intern over at the Cooperative Oxford Lab this summer. So a little bit about me. I am 21 years old. I am a student at New York University. I'm a rising senior. I'm majoring in environmental studies with a focus on marine ecology. So I've just got the logos there so that you all know, some visualizations. Just to get into a little bit of the daily routine, for most of my time at the lab, I was alternating between office work and field work, and I just wanted to give you a little bit of a taste of work at the office. Most of that consisted of just going over some frozen samples, from previous fieldwork efforts and measuring those and entering those into like the relevant data sheets. So I was doing a lot of working with frozen samples and then also database entry using RStudio. So for my first, I guess, first wouldn't be accurate, kind of like the guiding field work that was kind of my focus for this whole summer was Poplar Island. So everything revolved around that. And I performed fish community sampling over at Poplar Island. That project was headed by David Bruce, aka Paco, with Wilmele Cruz also. So I guess I want to give like a little bit of background. I think that's pretty important for how big this project is. So Poplar Island is an island, obviously, in the Chesapeake Bay. It was initially severely degraded. So back in the 1800s, there were over 1,000 acres of land on this island. And then fast forward to the 1990s, there were about 5 acres. So all of that had been kind of ruined by subsidence, erosion, etc. And this project started in 1998 with the U.S. Army Corps of Engineers and Maryland Department of Transportation. The goal was to restore the island, make it possibly economically viable, and create habitat. So my place in this, very small, I'm just like a little cog in the Poplar Island wheel, but our angle as NOAA Fisheries is to assess Poplar Island fish communities and see basically which habitat these fish show preference forward. So kind of a multifaceted goal. We want to see where the fish are going, see if they prefer restored marshland habitat or kind of unrestored, just natural areas. And I guess the goal of this would be, well, one, just understanding what the fish are doing, but two, also to inform future management decisions. So there's potential here to say, okay, because Poplar Island is a work in progress, like, are the fish, would it be more important for fish communities if we built upland marsh habitat, right, which is not water, versus low marsh habitat, which is water? So yeah, you can see there, that's just a map of kind of Poplar Island. You can see that it's split into a bunch of cells, and each cell is itself kind of a little restoration project. So this is all really big because it's not just like a self-contained thing, it's also informing future restoration work on other islands in similar environments. So those are some pictures I was able to go out with. Here you can see Apurva was there. I also went out with Julia Staranovsky. There's Paco. I'm making that little grimace in the left picture because I kept falling like in the bar. That's like my 3rd time, and I really didn't want to fall again. So moving on to another aspect of my field work, which was Bat Creek fish sampling. This is kind of a 2-parter. So our Bat Creek sampling was also in support of the broader Poplar Island goal. We wanted to collect data on fish communities in Bat Creek and just kind of cross-reference them with data from Poplar Island to see if there's differences. Again, see like where the fish are, understand fish movements, and we're doing this via acoustic telemetry. So I went out in June 1st just to get these acoustic receivers. I don't have any pictures of what they look like. It's kind of like it looks like a big hydro flask, like a black water bottle. We're using model VR2W acoustic receivers from Innovasi. And essentially what we're doing is there's a series of stations throughout Bat Creek, and at each station we have a receiver. We sink it into the water, and any fish that are tagged that kind of pass within a certain radius of that receiver, the data is like automatically downloaded into that receiver and flagged as a detection. So first step of our field work was just going out, bringing these receivers back in and downloading that data to see where fish have been. And the next part of that is getting some new tags out there and tagging more fish so we can keep getting data. You can see all of these numbers are a site where we put a telemetry receiver in the water. So there are a bunch of pictures as well. Can see there, Wilmeli caught a really big red drum, which was surprising. And if you're watching this right now, you're probably bragging about that. Can see up there. So that's, I guess it's a big thing that these things called fish bites. I'm not going to get into this too much, but they're like a bait that we weren't using before to catch fish for our tagging efforts. And I brought some over and they're pretty popular. So I don't know, hopefully I've informed future NOAA decision making for field work. And then just to talk about actually, I do also, well, I'll skip that later. So to move into my individual project, Atlantic sturgeon telemetry, this is another example of working on acoustic telemetry data, but this is separate from the Back Creek stuff and separate from the Poplar Island Fish Community stuff. So I just took older data that was collected by a bunch of fish taggers. And this is a big cross-departmental, cross-agency effort. A lot of these people were not in the exact same areas that we were in, so had to get specific permission. And I was just creating a series of summaries, maps, and plots using Atlantic sturgeon detection data. So there's two, I guess, important goals from this. So firstly, to understand the importance of our Chesapeake Bay backbone arrays and kind of inform both the public and the agency with this sturgeon data. I think it's obviously important to create visualizations. You're not going to get a whole lot of use out of just numbers for people who can't understand that. So obviously Atlantic sturgeon, endangered species, very important species. So this is meaningful work. And that picture is just from the sturgeon tanks that we have over at the lab. So just to explain what's going on here, this is an abacus plot that I made in our studio using Atlantic sturgeon detection data. You can see a bunch of different colored dots on a grid. And basically the easiest way to explain this is on the bottom you have dates. Then you also have on the left stations. So each of those stations on the left, you can see I don't know if you can read that, but Cedar Point 5, Cedar Point 4, those are individual stations where there was a receiver that an Atlantic sturgeon passed by, and then a detection was logged. And you can see the detections are those dots. So basically, the more dots you see, that's more consistency as far as detections being registered. This specific plot was sturgeon detections in 2022. We had 323 total tagged fish. And for our findings, so on the right, you can see more of the abacus plots, and on the left, these were maps of detections. I specifically took summer and spring from 2023. I could have pulled more. We had data from 2020 up through 2023, and it was split into different seasons. I think it's more meaningful if we read the data by season and not just by year as a whole. And so on a basic level, what you can kind of tell from this is you see there's more detections in the spring than the summer. So my conclusions I took away from this were, well, obviously there's significantly more detections in the spring than the summer. And why does that matter? Well, Atlantic sturgeon are an anadromous fish, so they migrate upstream to spawn, and then they move back out into saltwater in the ocean. And you can see, I don't know, well, it's not possible for me to zoom in, but take my word for it. On the left, in summer and spring 2023, spring has greater numbers. Summer has more variety in terms of locations of detections. We also have differences between, in each season and each year, how many sites there are. So that's important to take note of. I think, though, that our findings supported the idea of sturgeon moving upstream in the spring to fall, so going up into fresher water. What I was interested in learning about, though, that I have seen in literature about sturgeon specifically surrounding the Chesapeake Bay, but I didn't get, oh yeah, that's 2 minutes, thank you, was that there is a fall spawning run. I couldn't get anything to kind of support that. So maybe that's something to look into in the future. Just want to do a quick review of our core competencies that we were talking about earlier this summer. So I chose systems thinking. I think it's at the heart of pretty much everything I've been doing. Poplar Island is a really good example of that because you have all these different agencies that are involved, different levels of decision making, different focuses. You have people who are focusing on the engineering side. You have people who are focusing specifically on land management. You have people who are focusing on fish and marine. In the marine ecosystems, you have people who are focusing on birds, and it's a very interdisciplinary project. I started out giving myself a 4, and then I realized, no, now I'm at a 4. Like that now that I've done the work, I think I've come to a point of understanding where I'm just realizing, no, I'm still developing, I'm still growing. And then just really quickly, these were some opportunities for extra collaboration I had with people and groups that were not directly part of my project. So I got to do the sea turtle stranding alongside Henry Sage. I also got to do the Strand project and do some fish sampling there. I got to go out with Jay Lazar and check out on the hypoxia buoys. And the biggest, there were a lot of names involved. So forgive me if it's not all there, but I was able to attend a Poplar Island meeting where we got to see those management decisions and a lot of talk about engineering, full display. So I thought that was really interesting, and just seeing how many groups were involved. So I was not graceful enough to give you guys a content warning. Apologies. That's the sea turtle stranding. And on the left is a picture from the hypoxia buoy trip. I think, Sophia, you were there too. Yeah. Then just my acknowledgements. I want to give a huge special thank you to Wilmeli Cruz and David Bruce, aka Paco. I could not have done any of this without you. Thank you, Bart and Randy, for bringing me on. And thank you to every single person on this list, all the people who I was able to collaborate with, all the fish taggers whose permission we needed. So those names are obligatory. Yeah. I think that's it.
All right, thanks, man. Maria, we have up next. There you go, breathe.
You can just go to slideshow.
Yeah.
Yeah. All right. Good morning, everyone. Or yeah, it's still morning. Good morning. My name is Bria Pope. My mentor for this summer was Dr. Amy Freitag, and I want to do a brief overview of some of the work that I did this summer, and that was mainly evaluating the role of coastal infrastructure in arts and entertainment district protection in the Chesapeake Bay and the Baltimore area. So first, if we haven't met or had a chance to really get to know each other, I am a second-year master's student at Florida Agricultural Mechanical University. My school has a partnership with NOAA, and through that partnership, I had the opportunity to come up to Maryland for 12 weeks and work in the Cooperative Oxford Lab with Henry and Oliver, who you've already heard from, and participate in this internship. So after this internship, I do plan to go back to Tallahassee, Florida, where my university is, finish my master's degree program, and maybe apply to law schools. My goal in the future is just to be able to give my legal opinion, to be in the rooms with people who are making decisions on some of the issues that I was researching this summer. So I had two main objectives while I was working in the lab. The first one was to create a map portfolio, and the second one was to create recommendations for future infrastructure construction based off of that map portfolio. So in the portfolio, ideally, I would be able to visualize and accurately depict where coastal infrastructure is currently and how it relates to where cultural resources are, coastal infrastructure and where cultural resources are. So my general study area was a commuter shed of Baltimore City. So this is Baltimore City and the 5 surrounding counties. You can kind of see I overlaid the roads, so you can see like all the roads sort of lead to Baltimore. So if you've ever lived in maybe a state capital or something like that, you're aware that things that happen in that capital relate and involve more people than just that little center. The colors right now don't matter. I just wanted to show you guys the counties and maybe get a name in them. I'm going to reference them a little bit, but yeah, that's the general study area that we should kind of have an understanding for. So while I was creating this map portfolio, I had 3 main steps. Of course, there's a lot more, but I just wanted to condense things for the sake of time and accurately like expressing things to you guys. So first, I needed to understand the background of what was going on, the work that had already been done in the vulnerability assessment, how I fit into it, and then I needed to collect data, and then I needed to put that data into a map and make it look pretty. I will reference ArcGIS a lot. This is a program that I used to make maps. This is kind of what Mariah was speaking on earlier, the GIS mapping. So first and foremost, when I got started for a couple of weeks, I just needed to get oriented and understand how my work fit into this vulnerability assessment. So specifically, Amy helped a lot with that. There were a lot of members in the vulnerability assessment team that I can't really go into their work, but the reason I focus on cultural resources, and I've kind of narrowed it down to arts and entertainment districts for you guys, but my broader scope was cultural resources. I wanted to focus on those instead of maybe something like property value or some economic value to relate to coastal infrastructure so that I could accurately determine or accurately express the buildings that are being protected by coastal infrastructure that's not based off of money. So if you base infrastructure protection off of things like property value, you end up protecting maybe like $1 million homes or values or homes that are buildings in general that are more economically valuable instead of maybe things that are important to the entire community. So cultural resources, I had the task of determining what those things were, which was kind of difficult at first. I came up with places of worship, protected areas. The United States has a database of all of these areas that have been designated as such in order to protect things like biodiversity and community recreation centers. So these are things like parks, maybe important buildings that people have used a lot, and historic resources are another cultural resource. And of course, arts and entertainment districts, which I'll talk to you guys about a little bit. So for data collection, I use a lot of websites, but mostly I relied on people who I can't all credit, but George Edmonds at Maryland DNR was a great resource. He was instrumental in advocating for me getting some of the layers that I use to share with you guys. While I was making these maps, one thing you don't really think about is accessibility to maybe people with visual disabilities or colorblindness. So Color Brewer, this website that I have up in the upper right-hand corner, was a great resource to help me choose which specific colors to use. So a general overview, this is like a pretty literal or direct map of the things that I'm going to talk about today. I'm going to break them down county by county, but you see the arts and entertainment districts and the different oyster sites. As I was talking about earlier, this cultural resource is something that is accessible and open to everyone. Like it's not based off of, there's no division of only certain people of a certain economic value or economic background or demographic background in general. Everybody uses these things. And then coastal infrastructure, I'm gonna look a little bit into gray and green infrastructure. So to get through my first county-based map, I'm gonna go through arts and entertainment districts. So to orient you a little bit, I'm using the same colors, but there's actually a legend this time because the colors matter. Baltimore City has a higher concentration of those arts and entertainment districts, which is kind of expected. And then you can see kind of the opposite. It's not really showing up on here, but Queen Anne's County and Howard County have very low concentrations of these arts and entertainment districts. And that's just something to keep in mind for the next 2 slides I'm gonna show you. Oyster leasing and planting. So these have the potential to provide shoreline protection if they are as they are in the top left-hand corner, like on the shore, like if they're planted on the shore, then they can provide shoreline protection. But a lot of them are actually below the water, like they're bottom leases in Maryland specifically. So they don't provide a lot of shoreline protection, but it is important to know where they are and where we could potentially build off of. So this shows both restoration sites, which are plantings, and leases, which are sites that people make money off of. And we can see kind of the opposite. Queen Anne's has a high concentration of them, and Baltimore County has a very limited amount. And gray infrastructure is pretty much the same. Not much change, except for maybe Anne Arundel got a little darker. That might just be the saturation. But I did want to show you guys that this is something that's there and worth mentioning. And we ended up taking some pictures of it. Like I took 2 pictures on that slide. So in general, about 14%, 15% of cultural resources are at risk of being impacted by like a 2-foot sea level rise, which is a number that NOAA has projected. So I narrowed this down. This isn't based off of all cultural resources, but it's based off of the ones that have the potential to be protected or impacted by sea level rise and protected by cultural infrastructure. And this is all of them. This isn't just arts and entertainment districts, but I thought this was an important number to keep in mind. These are real buildings. 14% may seem like a small amount, but when you look at the picture, these are pretty large number of areas that might be impacted. So I actually had the chance to go to Baltimore City and take some pictures, take a little field trip, and ground truth some of the layers that I saw. So we saw all of these sites up here, but we went and visited a few of them and took pictures of them. And we saw in each one of them, we saw some degree, some aspect of coastal infrastructure. Now, if you came from Eastern Shore like we did, you saw Sandy Point Beach. There's no beach. It's just water. So they have something that's called sand fencing. I don't know what it's called. There's the first fence there designed to keep the sand and the grass in front of there in place and provide some protection, but it's not enough. The pier isn't high enough. You can see where the arrows are is where high tide was on that day. We went during low tide, but you can see if there's a 2-foot sea level rise, these areas aren't fully prepared or equipped to handle something like that. So the big picture is, in general, I want to advocate for protection of cultural resources and the coast in general. I needed to educate myself. I'm creating these map portfolios to inform others and potentially guide funding. And I did other stuff. I wasn't just making maps. Like that was me most of the time. But that's Oliver actually. We were interviewed by a radio show. I was cutting up the seal as well with Henry. I went to conferences and like thoroughly enjoyed their food. The Chesapeake Bay Environmental Center, and I turned into like a photographer. So I just wanted to say thank you to Amy for being an amazing mentor and someone who I could rely on to always come. And I never felt like any of my questions were dumb or anything like that. And everyone at the Cooperative Oxford Lab was very welcoming, and I thought it was a great summer. So thank you guys.
I was curious about why you included Howard County in the research of the maps, just because it's not on the bay. Like it has rivers and everything and tributaries into the bay, but it doesn't like have a shoreline.
So I wasn't the one who decided exactly what my study area was. I worked in partnership with the vulnerability assessment team, but I trust that they learned that this is a significant portion of the commuter shed. So a good number of people from Howard County commute to and from and are impacted by the things that happen in Baltimore City. So they are a little isolated. There's nothing on the shore, like you said, but it was a great litmus test for me. I could tell when things were going wrong in my map based off of Howard County because of certain things that should be happening on the coast, maybe that shouldn't be happening inland. So.
Thank you. Thanks. Next up, we have a board member. All right. Yeah. Mhm.
I gotta run, but I will talk to you soon.
All right.
Thank you.
You're welcome.
See ya.
Thank you. me see which one it is. Oh, there. Is this cool? Do you need to?
Yeah, I just want to know the
You know how to do it?
I think so. Sorry. Yes.
Yep.
Awesome. Thank you.
You want to go back over there and make it bigger. Let's go to slideshow.
I guess once you separate it.
Is that cool?
Yes.
Does that work for everyone?
That's my mouse. Okay. Great. Hi, everyone. My name is Apurva, and this summer I was the education work group intern based out of the NOAA Chesapeake Bay office, and I will be talking about my project, Charting the Future of Environmental Literacy. Just a little bit about me. In May, I just graduated from the University of Maryland College Park, where I received my degrees in community health and environmental science and policy with a concentration in environmental anthropology. And why I was interested in this summer internship at NOAA, I was really excited to work on a project doing qualitative community research, kind of combining those two degree backgrounds, health and the environment. And I was really interested in having the opportunity to have this government internship experience, which I've thoroughly enjoyed. So a little bit about my project. As I mentioned, I am the education work group intern. So I am based out of the NOAA Chesapeake Bay office in Annapolis, Maryland, but my project focuses on the work of the education work group, which works under the Chesapeake Bay program. My primary project this summer was convening a series of listening sessions to collect community feedback on the environmental literacy goal of the Chesapeake Bay Agreement, which I'll get a little bit into shortly. So this project supports the work of the Chesapeake Bay Program's education work group, and the information gathered through my listening sessions is compiled into a report and will be used to inform the next steps of the states across the watershed, informing their environmental literacy action plans, as well as the priorities of the education work group. So the listening sessions this summer, if you're unfamiliar with what listening sessions are, you can kind of think of them as like focus groups, but bigger. So I hosted lots of meetings with a lot of people asking questions to really prompt a lot of discussion and feedback from them. So over the summer, over 5 weeks, I hosted a series of 12 listening sessions at different levels. So some of them, we hosted one that was really meant to be region-wide. Some of them were with focus states of the watershed and of the region, like with Maryland, Virginia, Pennsylvania, Delaware, and the District of Columbia. And then some of them were also held at an organizational level, really trying to get in contact with and work with some key focus organizations that the education work group is trying to connect with more intentionally. So again, for a little bit of context about the project and the work, the definition of environmental literacy, it's something that a lot of people are pretty mostly familiar with, or you have a pretty good idea of what it is. But just to give a definition, environmental literacy is the ability to make informed decisions about the environment, act on those decisions, and participate in civic life. As I mentioned earlier, this project was to collect community feedback about the environmental literacy goals. So the goal is to enable students in the region to graduate with the knowledge and skills to act responsibly to protect and restore their local watershed. The goal is broken down further into 3 outcomes, which is not completely necessary to get into for this, but just to understand that there are different aspects of how this work is done, focusing on students, sustainable schools, and environmental literacy planning. So it's not just about, teaching about the environment, and it encompasses a lot of really intentional work in a lot of different spaces. So methods and activities of the summer. The first kind of portion of this was planning these listening sessions. So that involves, drafting questions, drafting feedback forms to go along with the listening sessions, drafting communications to our participants and people who we wanted to host the listening sessions with, planning logistics, and inviting participants. Then we moved to actually facilitating the listening sessions. So during the sessions, I was the main facilitator of all of the sessions, along with different team members. Shout out to Krista and Bart, who are sitting right here. I was the main facilitator, asking the questions and guiding the discussion, as well as we would have someone taking notes and recording the video and chat of each of the sessions for us to refer to later. Then the analysis portion of the project. Each session was transcribed and notes were added, really to make sure we got a full picture of everyone's feedback. Then taking these transcriptions and notes, we looked through and really close read all of these notes and transcriptions to identify keywords and quotes of interest. Then we took those quotes and themes and keywords and we sorted them into categories, kind of looking at different ways to think about what are people talking about, what are they saying, how do they feel about the actions and ongoing work towards the goal. And these themes were then further analyzed. Some of the results, these are some of the emerging themes that came up in some of our, as I mentioned, sessions with the focus states across the region, and they are ordered in from most prevalent to least prevalent, just the top 5 themes of each session. Now, on the left, under Delaware, I just wanted to point out as an example, these themes are really just the topics that people talked about. And when we were looking at these themes, we coded them not just for the topic, but then also what are people saying about them. So are they talking about opportunities they see in this topic? Are they talking about this topic is a real challenge for them or a real barrier for them to doing their environmental literacy work? Are they talking about really great or really poor examples that they've seen of this work? So getting into that a little bit more, I wanted to highlight as an example the topic of receiving support from administrators, principals, and the district. So this was a topic talked about across the board. But as I mentioned, we also looked at the different categories that people talked about. So when they talked about opportunities, again, these are some of the top opportunities that people discussed earlier. So if we look at receiving the theme of receiving support from administrators, principals, and districts, an opportunity that people talked about within that theme was about community and parental engagement. So for example, something that was talked a lot about in that session was if we get the parents involved, if we get the community involved, that inspires administrators and principals. That's a real driver for them to give us support. So I just wanted to highlight how the opportunities kind of relate to the themes and vice versa. Looking at some of the implications of the project, another thing that came up, which was really interesting, was that something across the board was that every single session, the participants and the co-hosts were really excited about hosting more listening sessions and having this opportunity again to connect with their community, to connect with other people, educators, administrators, people doing the work. And we also got a lot of really good feedback about how to improve the process. So 2 things that came up were representation and accessibility. On the representation side, a lot of people, one thing that stood out to me was talking about including student voices in the sessions, which I thought was really great. And as I guess a recent student, it makes me really happy to see that the people making decisions do want that voice included. Another topic that came up was just improving accessibility. All of our listening sessions were held virtually, and there were a lot of great points touched on about just different kinds of accessibility concerns to be able to involve and make the system and the process easier for more people to participate in. Another key highlights of the project were the sessions with the focused organizations, as I mentioned earlier. So kind of a surprise was to see how closely a lot of them aligned with the work of the education work group, and just thinking like, why weren't we connecting with these groups earlier? This is great. And another surprising thing that came up again, really across a lot of the different organizations we spoke to, was having an intergenerational focus, really involving families, along with just trying to teach students about environmental literacy, involving families, parents, grandparents, and the broader community. Just to connect to the major competency, the major competency that I saw most connected was systems thinking. And I wanted to highlight this model, the Environmental Literacy Network ecosystem. And this is meant to visualize the structure of how the education work group works collaboratively. And the model kind of shows where different things happen and how they interact. And the listening sessions did kind of touch on each of the different parts of the model. This summer and beyond, I wanted to also highlight the other opportunities of amazing experiences I got to have this summer. You've already heard about the Poplar Island field sampling, but Julia and I also got to participate in that as well, which was a real highlight of getting out to do some field work. I also really appreciated some of the conferences and symposiums I got to attend, like the Chesapeake Community Research Symposium. And also wanted to highlight next year, starting next week for Beyond, I will be participating as a Chesapeake Conservation and Climate Corps member, actually placed here at the Smithsonian Environmental Research Center, which I am very much looking forward to. And finally, a huge thank you to everyone I've had the opportunity to work with this summer. Most of all, my mentors, Elise, Shannon, and Meredith Lemke, the CRC staffer on the education work group. This is a picture from our first listening session over Zoom. Huge thank you for all their support and the growth that I've been able to have over this experience, and I've learned so much from them. And I also wanted to give a shout out to all my other interns of the cohort, and especially Bryn and Julia, my office mates. And this is a picture from the Mayo Youth Summit we got to attend in May. Thank you.
Questions? Yes.
Have you done qualitative research before?
Yes, so for those online, the question was, have I done qualitative research before? I have, though not in this kind of listening session format. I've had the opportunity in a previous internship to do ethnographic observations and research, which was similar in that it was kind of a long form qualitative analysis, but I have never been such an active facilitator of focus groups and listening sessions. So that was new for me. But the analysis part, I did have some experience in.
What do you think about listening sessions, as a method? Did you find that particularly, powerful, like it brought out a lot more? Or?
Again, for those online, the question was, what did I think about listening sessions as a method and about their impact, if I'm rephrasing that quite correctly? I found them really impactful. And I think another, I guess something that I didn't highlight as much about the project was that we had the listening sessions, and alongside them had a feedback form for participants who weren't able to participate in the listening session, just so that we can get a fuller picture. And one thing I really appreciated about the listening sessions was that it really allowed for a lot more discussion, and it allowed for people, for example, in the state and the District of Columbia listening sessions, it allowed for people working in the same space, it gave them another opportunity to connect and build off of each other. And in all of our state sessions, we had people using the chat, dropping their contact information for other people, saying, oh, let me connect with you on this, and I'm going to follow back with you on this, and sharing resources with each other. So I know that we got a lot of information out of the listening sessions, but I also felt like it was really great for the participants as well. And we got feedback from the participants that they also did like that format.
Thank you for the question. Thank you.
A shout out to Mayo and Laura Collard, one of my colleagues, and Emily at the CCCC program. Been partners for a while. All right. So from here.
Approval, while they're getting this up really quick. So like intergenerational comment that came out of the organization. It might be helpful just kind of like the organizations that you talk to.
Is that good?
Who were they? And just show up in the.
Okay.
Was there a way for me to see my slides on here though? So I don't have to like look at the slides.
So some of the organizations that we talked to were different sources.
And how do I change the slide? But now it's on the. That means I don't have to go back and forth.
We also talked to some of the coalition members from the Clean Water, the Chesapeake Bay Watershed, so a lot of different types of organizations.
Yeah.
And with
Actually, this
the
is probably
intergenerational,
because I'm moving the mouse back and forth to distract me.
basically that really
Slide
revolves
to the
around
right.
how they were
I'll just
talking
look at
about
this.
engaging with the community that supports students, like a lot of environmental literacy work, and the goal really focuses on students who are in K through 12 like school.
It's still not my time. We still have time.
Gave us a lot of context on what goes into like the community that supports those students, their parents, their families, and how that interaction, how we can improve environmental literacy, knowledge and actions in the community to also support students.
Let's not forget the Westmore governor's new executive order that he just dropped for environmental literacy, which I'm sure kind of plays a part in that. Okay. All right. So here we are with Julia. Thanks.
Hi everyone, I'm Julia. I was working at the NCBO office this summer, and my project was to really focus on the partnerships that are in the office. Oh no. Okay. Hello? Okay. So a little bit about me. I'm a rising senior at the University of Maryland in College Park. I'm majoring in environmental science and policy with a concentration in land use. And land use is kind of like a generic phrase. So to give you some context, I'll be doing GIS and remote sensing stuff as well. The reason why I wanted to apply to this internship was that I've always have like this fond memory and like love for the Bay. And I've always loved boating. I've always loved fishing. I love everything about the Bay. So I've always thought it'd be cool to do work within the region, as well as getting experience in a government role. And for postgrad, I'm hoping to be using those GIS or remote sensing skills and environmental career in the DMV or Philly, which is where I'm from. So about my internship, I'm the partnerships and engagement intern at the NOAA Chesapeake Bay office. And the main purpose of my internship this summer was to enhance and update the partnership systems management system spreadsheets and conduct informational interviews with the NCBO staff to learn about their partnerships. And the reason why this project was important for the office was because of the bipartisan infrastructure law and the Inflation Reduction Act funding that NOAA has received. There's been a lot more funding opportunities to provide to partners, and we have to have a way to track that information. And also with my interviews, hopefully this will inspire people to evaluate their partnerships in the future to help us inform strategic decision making. So this was the first part of my project, which was enhancing the partnerships management system components. So the two first bullet points, the partners list and the MSIs only, which stands for minority serving institutions, both of those were spreadsheets that tracked partnerships, and they have over 300 different individuals explaining where they work, and it's ranging from federal agency people, state government, nonprofits, academic institutions, and a bunch of places. The next two spreadsheets, the funding for partners and letters of support log, were both resources for us to track funding opportunities for partnerships and also to track what type of projects we have been able to support. And then those last two about partners projects, So the first one, it tracks all of the partners that we are related with and that they're applying for funding. So we have to track what funding opportunities are best suited for them and how we're providing them support. And then once those partners get the granted funding, then we move them into the partners funded project. And again, we track what grant they got, how much money they got, what project they're doing, and how we're facilitating them. And then this is the next part of my project, was doing informational interviews. And this helped me inform the partnership system management spreadsheet. And so these were the questions I asked in my informational interviews. I asked about their role and what the core elements are, who they work with, how they collaborate, how they would characterize those relationships, how they would want to improve their partnerships. And then I asked them about how they use the partnerships management system spreadsheets to be able to get some feedback on how it could be enhanced and improved. So now to my results. I broke down my results by branch in the office, and there are 3 branches. So there's the environmental literacy and partnerships branch, the ecosystem science branch, and the observations and monitoring branch. And this was a really simple way for me to structure it, because this was surprising to me that their responses to my questions were very different and they had a lot of different results. So through my interviews, there were 30 core partners that people named. So those were the partnerships people worked with the most. And now to get to the individual partnerships, this was what I learned from the environmental literacy partnerships group. Their partnerships are very innovative and very creative. They're constantly trying to do new things, constantly trying to find new partnerships, constantly trying to get people engaged, and they're always seeking new partnerships. And something to note was that the environmental literacy team is wanting to increase their work outside of the K-12 space. Next, for the ecosystem science branch, I learned that their partnerships and projects are very established and they're more steadfast. They're a little less innovative because there's less capacity for their work. In one of my interviews, someone highlighted that if they were needed to expand their partnerships, they'd have to cut out something else. And so it's really hard to make a decision like that. But they did note that they want to increase work with underserved communities and tribal nations. Lastly, the observations and monitoring branch. This was the branch of the office that has the least potential for expanding their partnerships, because they do very established partnerships and the relationships are very transactional. And what I mean by transactional is that all the work is very delegated in these projects. So each partner, each team has a very structured team for attacking the project. And so there's little capacity for expanding those partnerships. Next, I wanted to highlight some frequently mentioned partners. Notably, the most mentioned partnership was the Chesapeake Bay program, because it helps facilitate the work in the office through the Chesapeake Bay Agreement goals, and there's a very long-standing partnership here. I also learned about some of the challenges that are in the Chesapeake Bay program partnerships, and I also learned that many of the Chesapeake Bay partnership has the goal implementation teams and the work groups, which then creates partners more broadly. Next, VIMS was mentioned a lot. There's lots of partnerships projects that they facilitate, especially in the habitat focus area in the Middle Peninsula, as that's in Virginia. And they also assist with buoy maintenance and for the observations and monitoring team, and they provide information with their research to help our projects. Lastly, the Maryland Department of Natural Resources is a big partner for the office, providing technical assistance on many projects in oyster restoration, fish telemetry, climate resiliency, also buoy work, and they help plan and coordinate workshops in the environmental literacy branch as well. So for the discussion, I wanted to highlight the things that stuck out to me. But these are some of my general findings. Most, if not all, of the people mentioned in my interviews that their partnerships are mutually beneficial, and that there's always room for partnership growth, especially with underserved communities, tribal nations, and local communities. And that overall, I learned that people use the partnerships management spreadsheet as an outreach tool. So when they're thinking about starting a project or when they need people to reach out to, they look at that list and then they send any connections they need. And then these were some things that stood out to me. So again, to touch on the transactional partnerships. So there's a big difference between the way that the partnerships are characterized between those different groups. So for observations and monitoring, it's very transactional, but on the other hand, environmental literacy and partnerships is very focused on building relationships. And something I thought was really interesting was even though the teams that said their work right now isn't innovative and creative based on how the goals and the agreements are coming to an end as the Chesapeake Bay Agreement has its deadline, but they expect that things will become very innovative and creative as those new goals and implementations are going to come into place. So to touch on the competencies, I think that systems thinking played a role the most in my project this summer. Just have I had to think about how all the things intersected in the office and where they didn't, seeing the moving parts that are involved in the partnerships for who does what, and again, who does what for the roles of the partnerships. And then here's some of the fun things I got to do. We got to go to the Mayo U Summit and did the Build a Buoy activity. That's this picture down here at Sandy Point. And then I also got to go to some other conferences like the MACE conference and the Chesapeake Community Research Symposium. And then additionally with the partnership stuff, I was able to attend a lot of habitat focus area meetings as there's so many partnership projects and so much going on in those areas. So it was really interesting to sit in and listen to all the work that's being done. And as Apurva and Oliver highlighted, we got to do some work on Poplar Island. We didn't get to do like the gill netting, but we got to set minnow traps and we caught some really cool things. We caught a lot more crabs than we thought we were going to catch, but that meant they ate all the minnows that were in the traps. And throughout all these experiences, I really think it helped with my professional development. Something I learned this summer is to try new things. So I really thought this was a good way to do that. So what's next for me? A senior year is coming. I'm really excited to explore career opportunities and keep networking. And as what I learned, I want to say yes to more unique opportunities and trying new things. And I'd love to keep in touch with the mentors and my fellows. And just to say thank you, I thank you, Lauren, for being such a wonderful mentor and for helping me succeed. I've gained such valuable knowledge, and I can't believe how much this internship has made me a better person and a better professional. And thanks to my interns for being such great people too. That's all.
Yes. Julia, I am so curious about when you ask people across the partnership to characterize the relationship with the partner. Like, did you feel like a therapist? But what did you say?
So that question had a lot of sub questions. So I asked is the partnership mutually beneficial or is it a one-way relationship? Is it that's where the innovative and creative, steadfast and established, all those this or that questions is what I was going for. And so it was just really interesting to see because a lot of the times it wasn't this or that, it's both. And to see what weighs more than other and the different responses was really interesting.
So as a result of that, if you are looking for a partner for a project in the future,
yes.
Are there characteristics
For me, I think, yes. Based on the characterization questions I asked and what I learned from them, what would I do in pursuing a partnership in the future was the question. I think that the most important things in the partnerships are trust. I also think it'd be fun, I think that an innovative and creative partnership is really important just to be constantly thinking of new things to be accomplishing. And as well as having an established partnership is really important too.
When you asked that question about characterizing the partnerships, did you often have to ask, go down the list of the sub-questions, or do you feel like the staff members that you talked to, were able to talk about it without the sub-questions?
So Apurva's asking if, when I asked the characterization question, were the people I interviewed able to just answer that question, or were my sub-questions necessary for a response? I kind of, in my interview, I set it out so where they knew that I was going to be asking a bunch of this or that questions to help facilitate the question. Because I think that's a really daunting question to ask, because I don't know how to characterize a relationship.
I'm just curious if you guys have some people talking about their relationships, how well the partners were connected to each other outside of the NCBO pathway. Does that make sense?
Yeah. The question was asking about how the partnerships are interacting with each other outside of the NCBO office. Something that I was hoping to do that I didn't get as much time with, especially because I got sick towards the end of my internship. I was hoping to do interviews with the external partners to learn about their perspectives on partnerships, especially with NCBO, but also just broadly their partnerships. So that was something really interesting, and I still hope to do those informational interviews. Just I wasn't feeling my best.
Good question. Okay, thank you. And we do have some mentors here. If you're a mentor for the program, you just raise your hand or stand up. Maybe you want to stretch your legs for a second. There you go. All right, clap it up for them too. Yeah. Mr. Wang is a returning mentor, I believe. Mr. Wang, you're a returning mentor, correct? Professor Wang? No? Not here. What's this your thing here? Right there. Good.
Awesome.
Introduce yourself.
Yeah. All right. Hi, everybody. My name is Bryn, and I was the environmental literacy intern at the NOAA Chesapeake Bay office this summer. I'm really excited to talk to you all about my project. I know you're hungry for lunch, but hopefully you can be hungry for learning about climate change education. So with that, let's get started. So first, here's a little bit about me. So I actually grew up in the Annapolis area, not far from here. And while I wasn't always a huge outdoors person, I've always been passionate about education and problem solving. So now I'm actually about to start my senior year at Oberlin College, where I'm double majoring in environmental studies and economics. And this school year, I'm going to be doing my senior honors project for environmental studies. So I'm researching the question, does exposure to positive climate action by others increase efficacy and motivation to act? And I'm really happy to answer questions about that later if you're interested. And in general, I really do enjoy the communication, systems, and education side of environmental studies. And I definitely want to go to grad school down the line to study this. Not sure about the exact pathway, but that's okay. So as the environmental literacy intern this summer, I got to do a bunch of different things. So the first thing that I worked on was doing my summer project. So I spent a lot of time researching climate change education. You'll hear me refer to it as CCE throughout this project, just a little bit faster to say, but researching those CCE materials. I also actually created a CCE material. So there's something called the Environmental Literacy Model, or ELM, which is a way to design a meaningful watershed educational experience. And I actually designed mine about consumption in school communities. And if you're thinking, what is consumption? I mean consumption as in like using resources, not as like the old-timey disease, but you know, it can get confusing. And most ELMs and kind of environmental science kind of things are usually obviously based in science, but we recognize this kind of in the office that there's a growing need for more social studies focused environmental literacy education. So my ELM actually it's focused on consumption, and it's actually made for high school government classes. And finally, I also got to do work with the NOAA's Environmental Science Training Center. They do workshops, their summer programming, so I got to work at a bunch of different ones. So that first one is the Mid-Atlantic Climate Change Education Conference. Juliana Porva also got to do that. Porva did one of her listening sessions there. I also got to be a facilitator for the Mid-Atlantic Cohort Day of the Climate Generation Summer Institute. That was really cool. I did that with Elise. She's not here, but she is online. Hi, Elise. And then finally, this actually last week, I got to be one of the facilitators for Teachers on the Estuary with Bart and Krista and a few other awesome people. That was in the tip of Dorchester County. It was really cool. It was definitely a lot different than being in the office, but it was still awesome. So without further ado, let's get into my summer project. I'm also happy to answer questions about some of those other things I did later. But if you have any sort of familiarity with the Chesapeake Bay Agreement, or if you've been keeping up with climate change literature, or if you remember a Porter's presentation, you'll know that environmental literacy and effective climate change education are critical for building resilience to the climate crisis. And while there are quite a few CCE materials out there, we don't really know if they're designed in a way that would actually help build climate literacy and elicit climate action. So, recognizing this, last summer's environmental literacy intern actually started a project aimed at evaluating the current state of climate change education. So after lots of work, including things like informational interviews, research, and more, she was able to determine a really important set of evaluation criteria and actually gather over 270 different environmental or climate change education materials. So these are things like not lessons. Some of them were lessons though. Units, mini units, actual curricula, which is kind of like a more sustained sequence of learning materials, and some other things too. But there is a lot to look at. So the project that obviously I'm working on it too, but that Claire started had 2 goals. So she spent most of her summer focusing on that first goal. So she actually collected and began evaluating high quality climate change educational materials that school districts, curriculum developers, and educators could easily adapt to their specific needs. And this summer, I did focus on wrapping up goal 1, but I also focused on the second goal of the project, which is assessing how many materials for climate change education are both usable and transformative. So you can think about usability as in how easily could I adapt this to my school district or to my classroom, looking at things like standards or some other different attributes like paywalls. And then transformative is it going to elicit the types of thinking and action that are really going to lead to environmental literacy and climate action? So in addition to determining kind of the qualities of materials that you're looking for, so there are things that also are important, like place specificity, yes, which is kind of relating to how much is a resource related to a specific place. So you could be looking at air quality in Houston, or you could be talking about environmental justice in the United States. But there's also things like the resource type that are important. But there's also a set of special criteria that Claire determined that we actually evaluated using kind of a scoring system. So 1 is not present, it's not good. 4 is wow, this is exemplary, this is the kind of thing that we want to see in climate change education. So I'll introduce those categories now. So the first thing is actually standard alignment. Alignment with standards is really important because you want to be able to integrate things like climate education into more traditional learning. The second thing is student-centeredness. You want buy-in from your students and you want them to actually be paying attention. And more than that too, they need to have this sense of voice and choice to actually feel empowered in what they're doing. The next thing is social emotional learning. So most of you know here that learning about climate change is a lot and it can be super overwhelming. And this happens for students too. So if they don't have the right tools, they can feel overwhelmed, discouraged, and even depressed. And that is not good for climate action and climate literacy. Next is outdoor learning. You'd be surprised, but a lot of climate change education really doesn't do outdoor learning, which kind of feels antithetical to the mission of it, but it happens. But we want to see that. We do want to see that. Finally, we want materials to be justice-oriented. This is kind of a vague term, but what it means is that we want students to both feel represented, and we also want them to learn about kind of topics in relation to the systems of power and privilege and bias that really affect different issues in kind of our entire lives. And finally, we want materials to be action-oriented. Studies show that taking action is incredibly important for student outcomes and for eventually leading to greater climate action. So this is a really important attribute that we want to see that is not always seen in climate change education, but we don't really know the extent until now. So I had to do a few different things to really make sure that we had the right set of evaluation criteria. Claire had a bunch of great things, but sometimes it's good to have another set of eyes on an issue. So I started out by first interviewing a bunch of different curriculum specialists. So I asked them questions like, what attributes are you looking for in kind of different materials? I also asked them, based on the existing criteria that I have in my spreadsheet or database, what do you like or what do you dislike? It's good for them to give you the feedback that might be harder to hear. And then also, what resources or what should I add to this existing database? So this led me down a lot of different paths, and
a lot of them suggested that I check out different kind of like rubrics for evaluating educational materials. And that led me to websites like EdReports. So they use something called the EQUIP rubric to kind of assess the state of different materials and they give it a score, kind of like what I'm doing with this project. And at the same time, this article came out towards a transformative climate change education, questions and pedagogies. I actually said that word right, very exciting. But it was really cool that this article came out right after I finalized like the criteria, but there's a lot of alignment between what we kind of thought of as like being good qualities of climate change education and what these researchers also thought of. So that was really cool and supported a lot of the side research that I had to do to confirm the criteria. Okay. Perfect. So because of this, all this different research that I did add a few different forms of evaluation criteria. So some of these things are kind of more just like a checkbox or kind of like a little like blurb or drop-down list kind of characterizing the materials. So ease of access is looking at things like, do I have to pay for this resource? Like, do I need to subscribe to, or in order to access it? Is it open access? Is it privately owned by someone? These are actually barriers that like seem kind of simple, but can make a really big difference for people or just school districts more broadly. Also, because I'm based out of NOAA, we did want to look at how many resources use NOAA materials. So this can be looking at something like using the NOAA Sea Level Rise Viewer, or it can be that NOAA actually funded or collaborated on a project. And also we looked at discipline types. So what this means is that some materials are really rooted in like biology or science, which is kind of more of like an interdisciplinary focus versus something that is more issue focused. So maybe air quality in Houston, as I just said, might be considered more transdisciplinary, or there's things that are multidisciplinary where it's like combining social studies and science. So I also added 2 additional criteria that would be kind of rated 1 to 4, as with those other 6 that I just mentioned. So that includes career connections. So career connections are really important because sometimes people don't recognize the importance of like education as being really essential to kind of pathways for change and stuff like that. But there's a really big connection between education and kind of career skills and learning about actual careers that could help in the future. So this is something that curriculum developers and school districts are looking for, and we thought it was important to kind of start assessing that. And then similarly, especially school districts, curriculum writers really want to see that with resources that they might be willing to adopt or kind of base what they're working on off of, they want to see evidence of the design process. So this looks like things like planning, developing the resource, making sure it aligns with different standards, and then actually like seeing that it was implemented. It doesn't need to be like broadly tested, but people do want to see that like, hey, like we did this and it worked. So we also assess these 2 things. So with everything finalized, I was able to actually evaluate 100 of these climate change education materials. I didn't evaluate all 270. Some of them weren't really evaluatable too, but I focused on looking at those curricula units and mini units created after 2014. We know that climate literature is kind of changing all the time too, and there's different theories. So I thought it was good to kind of keep it within the last 10 years. And what we really looked at is how much did they align with the vision. So this is the vision of those 6 initial criteria that I mentioned. We want it to be like a 4 in each category. You kind of get this nice hexagon, I think it is. But with that, then we want to see like if based on these scores, does this suggest that materials more broadly are usable and transformative? So let's talk about the results. I don't know why I put transitions here, but I'm going to kind of explain what the different graphs mean. So this first one is a histogram of the average score. So each material was scored 1 to 4 for each one of these 6 categories, and then I averaged the scores for those. So you can see that it's like kind of a normal distribution, slightly less skewed or right skewed, skewed this way. And what that means is that most materials kind of scored in that average range. Like the 450 is misleading because you really can't get over that 4 anyway, but what that means is that a lot of materials have room for improvement. And this was expected, but ideally we'd want to see a lot of materials really scoring in that high range. But it shows that there might be areas where things did have a greater score, like categories where things are scoring better. And if you look down here, you can see what that like kind of looks like at a more category-based level. So things like standard alignment and student centeredness, which are those 2 on the left, they actually scored higher compared to the other criteria. And I don't really find this that surprising because standards are really important considerations for schools, curriculum developers, and student-centeredness. I'm honestly a little bit surprised by this, but it is important for students to actually be engaged. And I do think that, like, especially after the pandemic, kind of the nature of teaching and learning is starting to change a little bit. And then on the other side, you can see that outdoor learning, which is in red, and then social emotional learning kind of scored pretty low. And I'm not surprised by this either, but maybe outdoor learning a little bit. Like, it's like, you know, climate change and outdoor stuff. But these both scored really low, which is concerning because we do want people to have these skills and be able to connect with nature. And then finally, we can see that justice-oriented and action-oriented kind of had a score in the middle of those. So definitely suboptimal, but not to the extent that outdoor learning and social emotional learning scored. And let's see. So what can we glean from this? To me, these results suggest that creators do recognize the importance of usability. The standard alignment and some of the other criteria too that are kind of more just like attributes that we assessed, like it does make it possible for schools and school districts to implement these resources, at least to a greater extent than what could have been expected. And 75% of materials actually really are student-centered, which I think is really exciting. And it shows that like there's a lot of hope and push for students to get excited about learning and engaging with climate change. But we also can see that outdoor learning and social emotional learning are really not ubiquitous in climate change education. Here on the bottom, you can see the distribution of scores for outdoor learning. So 1 means it's like it's not present, and like over 60% of materials did not have any like desire to kind of include outdoor learning, or they really just didn't even, it's like a side activity. Like if you wanted to, you could do this, which is not what we want to be seeing. And then we can also see that justice-oriented learning is really variable. And what I think about this meaning is that some materials are like stellar and exemplary for kind of having this like environmental justice focus for climate change education, and they do commit to being anti-racist, while other materials really like these two, 1 and 2, to me, those are both just like, it could be doing so much better. And most materials, if you look at it, kind of have a majority of like a suboptimal scoring, which is not what we want to see for climate change education. We know that it's so important to consider justice and climate justice, environmental justice, social justice for learning, and it's just not quite what we want to be seeing. So we all kind of worked on a bunch of different skills during our internships, and while I do think that I built a lot of different competencies through my project, I think there's a really big connection between my project and this idea of civic responsibility. So climate literacy really is critical for informed citizenship. If you are not kind of connected with your environment and understanding the issues that contribute to different environmental outcomes, you're not really an informed citizen. And a lot of my criteria, like separate of climate change education outcomes, are important factors for civic responsibility. So especially that social emotional learning component, that includes things like social awareness and ethical decision making. These are all things that are really important factors for civic responsibility. And this last part is part of the description of civic responsibility, like this idea that hopeful individuals working together can make a difference. And I think this is a really big struggle for young people, is to think about themselves as having a big impact as individuals, because we hear all the time that it's like the corporations, or it is, but like it's also, we do need to have this like collective shift in consciousness and the sense of hope. And I think that proper climate change education helps people build that sense of hope and realize that they can work together to make a difference. And also that we need to hold, companies accountable. But I do think that's really exciting. And hope is a really powerful tool. And with that, I just want to say thank you. Thank you especially to Bart and Krista and Elise. I know you're online. You guys helped so much during this internship. I really did learn a lot. Also, I wanted to shout out to my office mates. You guys made the office very fun. And just everybody who helped me along the way. Frank, I don't know if you're watching too, but thank you so much for all of your help. And just everybody who was involved. That's a picture of me and my research group. Just kind of thinking about the future. That's where I'll be next year, or this year in like 2 weeks. But yeah, thank you so much, everybody. And with that, I can open the floor to questions.
We're kind of at the 15-minute thing.
Oh, never
If you have
mind.
questions, I would encourage you to ask them over lunch or put them in the chat, and Kristen will hit you up. There's cool.
Awesome.
All right, thank you for input.
Thank you.
All right.
So we had lunch over back there. They also, the 5 to the right, that whole road was all vegans. I think it was 5, but some people said that they would prefer that. So feel free to eat here. You can eat outside. There's a garden area right over there. You can sit to as well. And water right there as well.
And we're reconvening back in here, getting started at what time, Randy, was it?
Our next presentation is at 1.
Okay.
Can we gather 10 minutes before, because we'd like to take a couple of pictures before people disperse.
So where do you want us at 1:50? If it's not raining right outside?
Yeah.
Okay. Sorry, it's 12:50. Thank you. 12:50, not 1:50.
A lot of. Okay.
just if you were wondering.
I mean, okay. But we saw a lot of barnacle and algal recruitment this summer, as well as like, I don't exactly know what it was, but I did have to like power wash it off of a lot of sensors, but it was kind of like spongy, but also kind of looked like mucus. And it didn't smell great. But when the sensors come up out of the water, it's kind of easy to see where hypoxic regions might be. So on the left, those 3 sensors were at deeper depths than the 2 on the right, and the 2 on the right have significantly more growth than the 3 on the left. So they might be in regions where oxygen is limited. But the accumulation of growth can affect data accuracy and skew readings and actually affect the general functionality of the sensors. So that's why like constant maintenance is necessary to keep data accurate. For this project, I mainly worked in RStudio to make plots and do the analysis of the 2 different data sets. The historic data was from the Chesapeake Bay program, as I mentioned before, and I got the 2024 dissolved oxygen data from the hypoxia buoy system API. Next, I had to organize the data to get just the station depth and time frame that I wanted. So it ended up being station EE 2.1 at 5 meters from April to August of 3 different sets of decades. So the 90s, the 2000s, and the 2010s. I chose 5 meters because it was present in both data sets. It was pretty straightforward and has relevance to living resources. The historic data ended up being a lot sparser than the real-time 2024 data, so I decided to do monthly min, max, and mean to show like a broad spread of the data. And while the recent hypoxia data comes in every 10 minutes, so I had to aggregate that data as well and decided to do daily averages since it would be more frequent than the historic data monthly averages, but not so overwhelming like the 10-minute data would be. I still had to do a fair amount of like data manipulation to get both of these data sets to be able to plot on the same graph. So one thing that I did have to do was mess around with timestamps. The 2024 data has a universal standard time timestamp, which just has a lot more information to it than I actually needed. So I ended up just cutting out the time and only using the date. And then I had to change around the historic data dates to just be the first of the month since their exact date was pretty arbitrary. And then as for plotting, I went through a lot of different stages. First being more like exploratory and seeing what was with the data and what I could do with it. And then it more came to like figuring out how to do the individual parts to then all put on one plot. So then as for the plots, the dark blue line is the historic monthly maximum. The light blue line is the historic monthly minimum. The orange line is historic monthly mean. And then the black line is 2024 daily averages. So first, this is for the 90s. The historic range is pretty wide in the spring, but seems to shrink around the warmer months of like June, July, and August, which is a trend that will show up in the rest of them as well. And the 2024 daily averages seem to fit within this range. For the 2000s, the range seems to expand a lot more, but sorry, I lost my train of thought. The range expands a lot more, but there are still like some decadal monthly minimums that go below that 5 milligrams per liter where organisms start to get stressed.
And then the range also constricts around those warmer months, like in the 90s. And then for the 2010s, the general range just gets a lot smaller compared to the first two plots. And it appears that like the 2024 data, both the highest DO peak as well as the lowest points have dipped between that below that 5 milligrams per liter, whereas the 2010 means seem to stay above that. And then this final plot is just monthly means of the 3 historic decades as well as for 2024 and the daily averages. And at least to me, it just kind of shows that all the means don't really vary much from each other, but compared to the daily averages, it kind of shows that mean isn't really the best way to assess data that's so variable. For example, if we take a closer look just at like daily averages themselves in the water column and take just like the month of May for this year, this is what the hourly averages actually looks like. And it's a lot more variable than what like a max, min, and mean can show. So like, for example, if in the water column, DO was oscillating between like 12 and 2 milligrams per liter, a daily average would say 7, but that really isn't representative of what actually happened over time. However, like these parameters are good for like broad analysis and showing general trends. Hypoxic events have existed throughout geological history, but have been accelerated through anthropogenic causes, mainly excessive nutrient input, which could explain some differences between the historic data. Dissolved oxygen in estuary systems is, in its nature, varies temporally and spatially, but this is also due to like water column mixing and stratification and temperature and salinity and freshwater input that all factor into like the different variations over time. For future directions of this project, it would kind of be interesting to look at different depths to add a spatial component as well as like the rate of change of DO for over time, sorry. So like how dissolved oxygen levels change, how they fluctuate, for how long, to further give detail to like that living organism like squeeze. Over the summer, I think that the competency that I thought about the most was probably civic responsibility. At school, when I work in like labs, I feel like I'm just kind of collecting data for the sake of it, and it's not really, I'm so far removed from the final product or like the actual impacts that it will have. But compared to like this summer, I was doing a lot of hands-on work and cleaning to keep data accurate for both other people who use it and myself. So I had like a greater sense of responsibility. And also like at the beginning, Jay and I had discussed the importance of like the DO data to seasonal summaries and how like both the NCBO and its partners use that. So it was another kind of thought about how I fit in with the greater community and how my actions like impact other people if they see any part of this analysis or any part of the data that I messed with. I just want to say a big thanks to Jay, Max, Anthony, Taylor, and CJ for being great people to work with at the warehouse, but also being great mentors for the summer. NCBO and CRC for just the opportunity of this internship. And then also my parents for making it possible for me to spend the summer in Annapolis because I am not from Maryland. And that's it.
Questions?
I am so interested by the choice of civic responsibility as a competency. I think that is so insightful. And so when you had that line on there that your responsibility and how you visualize and present the data, can you talk about that a little bit more? Like what presentation of that data tells the story that you think needs to be told?
So like, at least with building the plots, I went through a lot of different variations of what could be shown and the different ways too. But then I also had like a lot of meetings talking with Jay and Max just about like what this actually says to people and does it make any sense? Because there was one initial variation that looked like it would work, but then at the end it was like, this kind of really isn't saying anything. So then it came down to like, almost simplifying the plots to be very straightforward, to be like, this is what the data looks like and people can use it however they want. And that's just like, we're collecting the data. It's not really much about me interpreting or drawing conclusions, but just like laying it out as this is how it is.
And then why did the range shrink so much from 2010 to 2019?
In that decade, I'm not sure why it shrunk so much. It could have something to do with like anthropogenic increases in like nutrient runoff, or it could just be like the times that the Chesapeake Bay program went out to get data, it just happened to be a smaller range than the previous decades.
So, okay, I'll see the question. So like the higher resolution data from kind of the sensors that you were looking at, hypoxia sensors, like that could have a bigger influence or impact on living resources, right? Like if it gets, I mean, you were saying like it could be down as low as 2 and then up to 7 in a day, or 10 in a day, then that median doesn't tell the story that maybe fish were stressed for a little bit, right?
Yeah, so like the higher resolution data, I think it would be more helpful for like living resources because of what you were saying. Like you can get more detail about what's happening in the water column and what organisms might be experiencing versus just saying like in August of 1994, the minimum was like 3 milligrams per liter. That doesn't really say what was actually happening at that time. Okay.
Awesome. All right. Thank you.
I don't know how to get out.
What's up? Good job. And next up we have Cami. Yep. Do you need to get notes or anything?
No.
All right.
Thank you.
Well,
My presentation is plastic party crashes, interactions of macroplastics and macroinvertebrates in freshwater systems. My name is Cami, and my mentors for this project were Dr. John Sweetman, Dr. Daniel Allen, and Mason Wood at Penn State. A little bit about me. I'm from Kent Island, Maryland, and I go to college in Washington College in Chestertown. I'm a rising senior with majors in environmental science and anthropology and a Chesapeake Regional Studies minor. At Penn State, I was a research assistant for aquatic ecology and environmental change, and that's in State College, which, if you don't know, is basically just the center of Pennsylvania. And I was attracted to this position because of experience with graduate level research, fieldwork in freshwater systems, and I got a lot of hands-on experience with my macroinvertebrate identification skills. So I'm dual advised between the Allen Lab and Sweetman Lab, so we have a lot of different projects going on. In the Allen Lab, they're assessing the feasibility of assisted macroinvertebrate establishment for ecological uplift in restored streams as part of the Streams Climbs project. So what that means is basically moving macroinvertebrates from a healthy stream to a restored stream. And so if you restore the macroinvertebrates living there, then hopefully overall stream health will improve. Sweetman Lab, we focus on factors influencing biodiversity of macroinvertebrates in vernal ponds, which are ponds that dry out for portions of the year and then get refilled with water. And there are 2 people in the lab working on that. So chemical contaminants, specifically the pesticide tebufenicide, which they spray for spongy moth, and then microplastics. We work throughout Western Maryland and Central Pennsylvania with partners at the University of Maryland Center for Environmental Science, CB Trust, Maryland DNR, Anne Arundel County, and then PA DCNR. For my independent research project this summer, I looked at macroplastics and macroinvertebrates in freshwater systems. If you don't know what a macroinvertebrate is, they're aquatic insects, worms, snails, crayfish, and other crustaceans that live part or all their lives in the water. And they can be impacted by plastics by the way they feed. There are 4 functional feeding groups for macroinvertebrates: shedders, collectors, grazers, and predators. Macroplastics break down into microplastics within the stream, and then these microplastics get incorporated with organic matter. So for these shedders and collectors, when they eat the organic matter, they're also ingesting parts of microplastics. Grazers graze off of algae on the surface of things underneath the water, and if the surface happens to be plastic contaminating the stream, then when they graze the algae, they're also grazing part of the microplastics. Then predators eat these macroinvertebrates, and it can bioaccumulate up the food chain. Habitat-benthic living means that they're just living at the bottom of the water, and if they're living and eating in this plastic, there's more of a chance that it ends up in their system. So for this experiment, we predicted that plastic litter type in streams will affect macroinvertebrate richness and diversity. We had 5 different treatments made up of 4 different types of plastic. So Ziploc bags are low-density polyethylene. Black trash bags, another low-density polyethylene, but black instead of transparent. Compostable bags, which are BPI, commercially compostable certified. Shopping bags, a high-density polyethylene. And mixed plastic bags, a combination of the 4 types of plastic. We cut these into strips so that they would be the same size, and I wouldn't be biased off of that. We measured them and put 30 grams of each into a traditional mesh leaf pack bag, and we traveled to Shavers Creek in central Pennsylvania, where we completed our study. Every 15 meters there was a rebar with the 3 repetitions of the same type of plastic until all of them were out, and we left them for 4 weeks following leaf pack network protocol. After the 4 weeks, we traveled back and collected them and brought them back to the lab. Macroinvertebrates were sorted and identified the family level, and abundances for each of those families were recorded. And we calculated richness and diversity using R. So these are what our results look like. We have richness on the y-axis and treatments on the x-axis. The letters at the top represent treatments that were not statistically different from each other. So if they have the same letter, then they weren't different. The differences you can see here are between mixed plastic and Ziploc, with Ziploc bags having statistically less diverse macroinvertebrate families than the mixed plastic bags. Here we have Shannon diversity on the y-axis and treatments on the x-axis. You can see we have differences between both compostable and Ziploc bags, both of those being statistically less diverse than the mixed plastic bags. And here's a look at what our community composition looked like for all 5 of our treatments in total. As you can see by the big blue area, in all of our treatments, the most abundant family was chironomids, which are the little one up there. They're non-biting midge, which we would expect that to be the most dominant in our stream system. But after that, you can see dominance changes, both in shopping bag and trash bags. It's Philopotamidae, which is a species of net-spinning caddisfly. Mixed plastic, our next dominant was actually snails. Compostable, we have Ashnids being the second most dominant, and that's a darner, a dragonfly nymph. And then Ziploc bags, we have a different species of caddisfly. Here are pictures of what the organisms actually look like, if you wanted to know. So chironomid, again, being the most dominant. And then we have 3 species of predators that we had in our plastic leaf bags. Corygallids, which you may know as helgamites. Aphnids, which is the dragonfly nymph. Coleopterids, which is a damselfly. Heptageniidae, a flat-headed mayfly. Both Hydropsychidae and Philopotamidae are 2 species of the net-spinning caddisflies. And then Elmidae is a riffle beetle. And these were just some of the organisms that we saw. So originally we had predicted that maybe we would see differences between the two types of low-density polyethylene, the black trash bags and the Ziplocs, but that wasn't supported by our data. We might have thought that because the black trash bags could attract more heat and more algal growth, which could attract more macroinvertebrates, but Instead, we saw differences between mixed plastic and Ziploc bags and mixed plastic and compostable bags. We think this might be because of just within the mixed plastic bag, macroinvertebrates could prefer different types of plastic and it still would have been present in that bag. So we just got a greater diversity. Also, because of the different plastic types, they weren't able to sit flush against each other in the bag, like some of the other plastics. So there could have just been greater surface area for them to establish themselves within. And then the difference between Ziplocs was found both in diversity and richness. And so we think this might be because they were the transparent material, there wasn't as much algal growth, and then there wasn't enough area for macroinvertebrates to hide, so they didn't prefer to live there. There's plans for the study to continue into the future with longer study period and multiple collection points. So we collected all of our samples after 4 weeks, but maybe doing collections at 4 weeks, 6 weeks, 8 weeks. Also measurement of chlorophyll accumulation on the plastic surface and measurement between weight gain versus weight loss with algal accumulation versus like degradation of the plastic in the streams. Including a traditional leaf pack to compare with the plastic ones, and more repetition. The competency I focused on was systems thinking. In my opinion, macroinvertebrates are the ultimate organism to think about systems thinking because of their connection between the aquatic and terrestrial zones. So insect larvae and nymphs that spend their youth in the water then emerge as adults and become prey for terrestrial predators. Because they're an important environmental indicator, they have known pollution threshold measurements. So when a stream is unhealthy and doesn't have some of the more sensitive macroinvertebrates to this side, like the stonefly, caddisfly, we know that there may be some pollution problem in the stream, but we don't know the exact cause. So we have to look at the entire system when we think about like research questions and also methods to determine what is going on with that stream. In our lab specifically, we think a lot about the agricultural system and both with pesticides and also just management practices with nutrients and other things entering the stream and impacting it. We also think a lot about spatial and temporal systems. So we're in the center of Pennsylvania, which as you can see on that graph is in the Chesapeake Bay Watershed. So what happens in our streams flow down and impact the Chesapeake Bay. And then we think a lot about climate change with temporal changes and with the seasons. So for the vernal ponds and also ephemeral streams with the drying cycles that can impact macroinvertebrates coming back to the same area, and also with emergence times for macroinvertebrates. Then I just wanted to thank John, Mason, Emily, and Jordan for welcoming me to the Sweetman Lab and helping me with this project. Me some awesome field work where I did some eDNA work, and the Chesapeake Research Consortium for providing me with this opportunity. And that's a picture of a stonefly crawling around one of our traps. Thank you.
Yeah. Did you have to ID all these macroinvertebrates yourself? And if so, how long did that take? How difficult was it?
For my project, I did identify all of them with the help of Mason. He's the PhD student in the lab. And I did them all within the week, so it wasn't too bad. For his samples, it was about 3 of us working on them for like the entire rest of the summer, so yeah.
Do you think that the HTP versus LDP might have played a role? Like high density polyethylene probably breaks down less easily, and so maybe in the plots with the LDP or compostable, it allowed more of the plastic leaching that they made them less willing to establish.
We also did like weight measurements before and after for the bags. I didn't include it on this presentation, but the compostable were the only ones that lost weight. All the other ones gained weight, so that could definitely have something to do with it. Yeah.
Can you imagine that, like, could you inform management about, what types of plastics should be banned or, what would be the management implications?
I think definitely like having knowledge about which ones are the most detrimental to macroinvertebrate health to maybe be more focused on efforts to prevent those from ending up in the stream or from banning them from being used altogether, but also just not with policy as much, but just for stream health to know like what is going on with the macroinvertebrates and connections between what plastics are in the stream and what plastics are ending up inside the macroinvertebrates. So if there's like plastic that ends up in the streams, but macroinvertebrates don't tend to live in it or eat it, then maybe we can be less concerned about that. Thank you.
Awesome. Thank you.
Right, coming up to the podium, we have Melinda.
Can you hear me okay? Can you hear me now?
I think she's online. Oh yeah, she's on. Hey, Melinda.
I'm not sure if you can hear me from your end.
Say that again.
We can hear you.
Oh, are you able to hear me at this?
Yes. Yep.
Oh, okay.
Would you like me to share my screen, or you want to share your screen?
Would I able to share my own?
I can't hear. I'm sorry.
Would I be able to share my own screen?
Yeah, you can.
Okay. Try to get that.
You can start whenever you're ready, and I'll just turn it over to you.
Okay, perfect. Okay, can you see that okay?
Yes.
Randy, are you able to show this on the symposium screen? Oh, thank you. Perfect.
Does that work, Melinda? You good?
Yes. Thank
Good.
you.
All right, so without further ado, I will welcome Melinda to you all. She's virtual. And where are you at, Melinda?
I'm in Portland, Oregon still.
Nice. Okay. Well, without further ado, I'll turn it over to you.
Okay, perfect. So hello, everyone. My name is Melinda, and I was the Knowledge Graph Visualization intern for this summer. My mentor was John Wolf with the USGS, and the title of my project is Goals, Groups, and Graphs, Visualizing the Complexities of the Chesapeake Bay Partnership. So first, a little bit about me. I am a rising sophomore at Cornell University. I'm currently still undecided since I still have a year to pick a major, but I'm bouncing around between statistics, bio, and info sci. Not sure about my future plans yet since it's still kind of early for me, but I know I want to keep doing a multidisciplinary field, dealing with data, and then potentially grad school. So what attracted me to C-Stream is I grew up in hippie Oregon, so the environment has always been very important to me. I actually did algae bloom research in Portland for 2 years, and then I did algae bloom research for a third year at Cornell. So in this upper right corner, this is me taking plankton samples in the Willamette River in Portland. So I wanted to combine my environmental science background with the CS classes that I took at Cornell. And it seemed that this internship, this knowledge graph internship, was the perfect way for me to do that. And then in this lower right corner, that's me with my research team at Cornell. So first of all, what are knowledge graphs? So a knowledge graph is basically just a network. If you think about social media, you have like mutual friends, that's a network. If you've ever seen like these maps of flight connections, that's also a network. If you ever did those like connect the dots drawings when you were little, that's also a network. So basically the terminology for knowledge graphs that we use is you can see in this chart in the lower left corner. So we have something called a node. It's also called a vertex. And you can have multiple nodes, and the thing connecting those nodes is called an edge. This edge is basically just a relationship between the nodes. And these edges can have direction, as you can see in this chart, or they can have no direction. So these graphs can vary a lot. Like if you have only 3 nodes, like the chart I just showed, looks pretty simple, pretty self-explanatory, but as you add more and more data, as you can see, it gets more and more complicated. And with real life scenarios, there are hundreds and hundreds of nodes because there's just so much data out there right now. And when you have so many nodes, when you have thousands or millions of nodes, you get this very jumbled looking thing on the right called a data hairball. So what does knowledge graphs have to do with the CPB or CBP? Sorry. It is very complicated, literally. So at the beginning of my internship, John sent me this wonderful chart on the left. This is a chart showing the logic of the Chesapeake Bay Watershed Agreement. I'm sure you all are already familiar with what the agreement is, but in case you aren't, the agreement is basically like the kind of like the guideline for the work of the Chesapeake Bay program. And within this agreement, there are something called goals, and there are outcomes supporting these goals. For example, one goal would be water quality, and then the outcome of that water quality goal would be reducing toxins. However, because of this agreement model, the organization of the Chesapeake Bay program gets really, really complicated. If you can see here on the right, this is the website of the Chesapeake Bay program and how they're organized. As you can see, there's goal implementation teams, there's various councils and committees, there's advisory committees, and then within the goal implementation teams, there are work groups, which makes things even more complicated. So all in all, the overall structure of the Chesapeake Bay program is it's supported by the Watershed Agreement. There are 10 goals within this agreement, 31 outcomes under those agreements. 31 outcomes under those goals. And then under those outcomes, there's many, many more things, as I will show you later. So this is where knowledge graphs come in. So the Beyond 2025 Steering Committee received feedback that the Chesapeake Bay Programs organization was too complicated, as I just explained. However, knowledge graphs are perfect for this complexity because they can communicate how complicated the Chesapeake Bay program is. And because knowledge graphs are also a very efficient way to store data because of the relationship system, knowledge graphs are also a great way to sort through this complexity. So that is where I come in. So I help the CBP community community communicate how the program's databases, scientific tools, work groups, and more support these 10 overarching goals and 31 outcomes by visualizing these complex relationships as interactive knowledge graphs. And so let's get to the graphs. So this is my developer view. But all of these graphs are on publicly hosted websites. So if anyone wants to be able to see these graphs later, I'd be happy to send the URLs to you. But this is how it looks like on my end as the developer. So one of the main graphs that I developed was this goals and outcomes graph. So it looks pretty simple. All these green nodes are the different goals in the agreement model. And these pink nodes are the outcomes connected to each goal. However, the cool thing about this graph is I can zoom in. Let's say I want to see everything connected to the tree canopy outcome. I can expand this node and everything connected to that outcome will show up here. So as you can see here, these are different databases, different tools, and different watershed organizations connected to this one outcome. Another cool thing about this graph is we wanted to make it user-friendly. So if I want to look at just one of these goals in a different window, I can click on this and it'll show up in this filtered view. And even within this filtered view, I can expand the node and be able to see things in a more close view. So all of my graphs basically function this way. Another main graph I created this summer was this partnership and membership graph. Let me try to expand this. So this is where we also get into layouts. So graphs also have different formats, obviously. Like you have this format called radial layout, where it's very circular, very condensed. And you also have something called a force-directed layout, where the graph program automatically tries to separate everything. And each of these layouts has its benefits. With force-directed, you're able to see the structure of the network. However, if there's too many nodes, it can look really jumbled like this. This is what I mentioned before. This can kind of look like a data hairball. But with radial, for the sake of being able to be user-friendly, this radial layout is really good for being very condensed, very nice to look at. But as you can see, if there's too much data, it also gets really jumbled. But this graph is also interactive. So let's say I want to look at a work group. Before I get into the filtering, I should probably explain what this graph entails. So this graph shows all the work groups and goal implementation teams that I mentioned before within the Chesapeake Bay program. And then all of these light blue nodes here are all of the members connected to those work groups. I also added a feature where anyone connected to the USGS, because my mentor is with the USGS, has a red node. So let's say I want to look at local leadership work group. If I click on that, we can see just that work group within this view. So that way you're able to still be able to see the whole graph in this window, but you can still filter it down in another window. And with this graph, you can see the different kinds of relationships each member has to the work group. Like you can see the chair, you can see the coordinator, you can see the staffer. And another cool thing about graphs is you're able to see how many relationships each node has. So let's say I wanted to find the member with the most connections to a different work groups. So I can go to this table here, I can sort it by descending, and it looks like Peter Tango is the one with the most memberships. If I click on this, I can see all of his memberships. So most of my other graphs also work this way. As I said, we also made a data outcomes graph where there's different databases and how those databases support different outcomes. There's decision support tools, if it'll load. Yeah, so these are different tools developed by the Chesapeake Bay program and how those tools support outcomes and then what goals those outcomes are under. Same thing with this graph. This is the USGS scientists and their cost centers around the country. And then this one is watershed organizations within the Chesapeake Bay program. So I will skip this for now since I'm running short on time, but this was a bit challenging. The main challenge that I ran into this summer was having to change softwares. So originally we used something called Amazon Neptune, and unfortunately the problem with that program is you couldn't publish the graphs publicly, which is problematic because we want to be able to have people access these graphs from anywhere. So we ended up using a program called Neo4j, and that is the program that I used to make the graphs you just saw. Neo4j is written in a program called Cypher. Cypher is a graph query language specific to Neo4j, but Cypher was also really frustrating because no one uses it. So there was a lack of documentation, there was lack of help on forums. So a lot of it was just me brute forcing the code and hoping it'll work. The main competency I focused on was system thinking because obviously my whole project was being able to visualize the system. And the main questions I had to ask was who is using these graphs? So I need to think about the user point of view instead of my own, and also what would be the best way to contextualize these systems using these graphs. So I don't have many fun pictures since I've just been holed up at home in Portland, but I was able to visit Maryland for the very first time during orientation. And my biggest takeaway from being able to do this internship is I actually used USGS data in my algae bloom research. for the past 3 years, and it was really cool to be able to go from using their data to contributing. I also was able to gain knowledge on how to make these graphs. Whichever field I end up going into, there's probably going to be a graph. If there's data, there's probably a graph. So it's a very, what's the phrase? It has wide applications everywhere. So thank you to my mentor, John, for being a wonderful, wonderful mentor this summer. Ever since the interview, I knew he was going to be a great mentor. Thank you everyone at C-Stream, everyone on the GIS team, and thank you to Dave Kitkin as well for helping me with my data. Yeah, so that's it from me.
Kristen, do you want to ask your question?
I think you guys can hear me. Can you hear me? I was hearing a little feedback. Can you hear me, Melinda?
Yes, I can hear you.
Okay, great. I'm Kristen Saunders. I'm the cross-program coordinator in the Bay program, and I am so thrilled to see this presentation of graphs. I put a note in the chat that I love the word data hairball. Somebody described our work as a plate of spaghetti, but I like data hairball better. I think it's very accurate. But my question for you is, as John probably told you, we are in the process of looking at how we can not just organize our work going forward, but also reorganize our organization to be more efficient, more streamlined, to try to better connect things that are not necessarily integrated right now. And so I'm just curious of your thoughts on how we could use these systems that I love the graphs that you've put together. If you have some thoughts on how we could use them to inform our work going forward, as we look at the efforts to strengthen our partnership, to better connect the dots, and also maybe be more efficient in our work, but truly understand where all these complex connections are. And I think you've got a great visual way of showing everything. We didn't really have anything like this before. So I'm just curious what your thoughts are, how we can use this to inform our work going forward.
So that's a tough question. Just off the top of my head, I think especially the graphs I made where you can see the hierarchy of the goals, the outcomes, and then the different things connected to those outcomes. I think that's useful just for seeing like how everything fits in within the greater structure of the Chesapeake Bay program. So I think those hierarchies would probably be the most useful.
And just a follow-on question, because I think, I can see a use for some of this work that you've done as we go into those conversations. So I'm hoping that either John is able to continue accessing this, or perhaps we can bring you back for some meetings in the future to help us see. I think people intuitively feel the complexity of our organization and they feel overwhelmed by it. But being able to see it and manipulate these things and try to move the pieces around might help us zero in on some connections that we haven't thought about before. So I'm hoping we have access to this in the future in some way, whether it's through you or John or someone else.
Oh, for sure. I think someone I worked with this summer, Bailey Bosley, is going to be continuing my work while I'm gone at school.
Great.
Yep.
Oh my God. Thank you, Melinda.
Thank you.
Appreciate it. Let's give a round of applause for Melinda. Moving right along, we have Emma. Let's clap it up for Emma. you need to pull your notes up?
Yeah, I can do that.
Might need to reshare your screen again.
For on Zoom. Oh, well. Okay. How do we force this in?
Move the cursor to the left, yep. And then go here. Oh, wait, go. Share screen.
Okay, good.
All right, Emma's up. Thank you very much. And
Hi, everybody. My name is Emma, and today I'm going to be talking about my work at the Virginia Institute of Marine Science, where I helped optimize the environmental justice mapping tool for the Elizabeth River project. Okay, so a little bit about me first. I'm originally from Texas, and then I moved to Oregon to go to Oregon State University and pursue my bachelor's degree. And then this past June, I graduated with a degree in marine studies, specializing in environmental justice. And then I was drawn to this internship for a couple of reasons. First, because I did a C-Stream internship last year, as you all may have heard earlier. And I worked with the NOAA Chesapeake Bay office last time, and it was a good experience, and I liked it. And then also just because I've worked with my mentor, Dr. Molly Mitchell, a couple times in the past, and I was excited about the opportunity to work with her again on an environmental justice related project, sorry. And then since I graduated mid-June, I sort of started my internship a little bit later than everyone here. So what I'll be talking about today is basically the things that I've done in the past 2 months and then what I hope to achieve moving forward in the next 3 weeks. So a little bit about my internship. Of course, it was focused on environmental justice, and it involved creating tutorials for an environmental justice mapping tool that was created back in 2021 by the Virginia Institute of Marine Science. The tool was created specifically for the ERP, Elizabeth River Project, for their use in restoration planning. So that way they could include environmental justice themes in their work. And because of this, the tool is just on its own very complicated. There's over 40 layers. There's just a lot of data in this tool. So my task was sort of to create a couple of story maps using ArcGIS to help make this complex tool a little bit more accessible to the community. And then I moved, well, since I went to school in Oregon after graduating, I drove all the way here to Virginia, oh, not here, but to Virginia to be able to work here. And yeah, and I think it was worth it. I think it's been fun to explore the East Coast a little bit more and work on site at VIMS. And then more about my project. So the first thing that I had to do was make a main story map showing all the functionalities of the tool. So basically just showing, talking about what the tool was made for, what the tool is, and then going more into specifics. And then the next thing that me and my mentor talked about was making mini story maps, which are essentially case studies to depict even further how the tool can be used for the community. So a couple of those case studies are seen here. The first one we talked about was changing flood risk. So how can you use the tool to look at sea level rise projections and storm surge projections. So for example, flooding that would occur like if a hurricane happened, how you can use that tool to look at how that affects facilities and roads leading to those facilities. So facilities could include medical centers and ambulance centers. And then, sorry, I need to breathe. And then the next one was restoration opportunities. This one's a little bit, this is just basically looking at areas that are suitable for restoration opportunities, like implementing living shorelines or maybe tree planting projects in areas that don't have much tree canopy. And then the last one would be exposure to hazardous materials. So this one looked at how you can use the tool to look at the proximity of communities to hazardous sites like Superfund sites or brownfield sites, which are areas that have presence of toxic materials in the ground. And then now that I've talked to you a little bit about the project, I'm going to walk through my process of making these story maps. So the first thing that I had to do was learn about the tool. Obviously if I'm going to make a tutorial about it, I have to know what I'm dealing with. So I got familiar with the tool, looked at all the different layers and all the different buttons and took some notes on like things that I wanted to highlight in the tutorial. And then after that, I talked to a contact at the Elizabeth River Project, got their feedback on what they wanted me to put in this tutorial and highlight. And then afterwards, I outlined and brainstormed how I wanted to organize the story map since there was a lot of information and trying to think of the best way to communicate that. So what I came up with was just sort of starting with an introduction and then going more into specifics. And then the next thing was just taking lots of screen captures and screen recordings. So here's some examples of like those screen captures of the tool, and then just adding like layers, or not layers, but arrows and like labels, so that way you know what you're looking at. And then after that, just more discussions with my mentor, just to get her feedback and improve the story map. And then I also worked on those 3 case studies that I mentioned, which are essentially the mini story maps. And so a video should play, but basically what I created was a main story map and then the 3 case studies. And so this is just an example of one of the case studies that I did. So you can sort of see me scrolling through it, and there's just different steps that I had for the users to follow with using the tool. And then some of the things that I learned, I've had experience using the story map function before, but I definitely learned more about using that and what the best way is. Also, I meant to mention that you can scan the QR code and that will take you to a collection of all the story maps that I made. It's kind of hard to show story maps in a presentation because it is like a living product. So the best way really is to scroll through it yourself. And then also just navigating mapping tools. I have had limited experience with mapping tools in the past, but this internship allowed me to really dive deeper into that and understand what all these layers mean. So yeah, and then this is just an example of one of the story maps I made. And then I also want to talk about other things I got to do during my internship. So I got to join in on a couple of high school interns, their project at VIMS. They were looking at benthic microalgae and the abundance of them in living shorelines. So I got to go out with them on the marsh and collect some samples. It was not at all related to my project, but it was really interesting and fun to get that experience. We also got to look at those samples in the lab. And then I also got to attend a workshop in Matthews County, Virginia, which they call soggy workshops because it's about flooding and inundation. And so that was essentially an educational workshop that showcased resources and tools for the community to use to learn more about flood risk in their area. And then I also reached out to a lot of people while I was working at VIMS just to talk to them about their experience. I reached out to grad students and people working at VIMS just to learn about their jobs and learn about graduate school. And then I also got to tour the VIMS labs and some of their collections, which was fun. So yeah, it was a pretty fun summer. And then as you've probably heard everyone say, systems thinking is a pretty big competency, but there are 4 main areas: civic responsibility, systems thinking, multicultural awareness, and ethical reasoning. The one that showed up for me a lot in my internship was systems thinking, as you can see here with Hello Kitty. I just think like using the tool, seeing all the layers and how they interact with each other and how you can make connections between them, looking at the socioeconomic factors, the environmental factors and how those connect is just, I think pretty representative of how you should always be thinking in a system when it comes to environmental issues. And then just to talk about what's next for the internship, also fun fact, this fish is named Batman, and he is at the aquarium at VIMS. So I got to meet him too. But yeah, so what's next for the internship is to gain some feedback from the Elizabeth River project so they can look at my story maps and see what needs to be improved. Also talking to hopefully some community members within the Elizabeth River watershed, and then people at VIMS that I've just made connections with who are willing to look at my story map. And then basically utilizing that feedback to improve the story maps and the case studies, just so it can be as smooth as possible for people who are interested in learning about the mapping tool. And then after my internship, I'm returning to the Pacific Northwest, actually in about a week now, and I'm going to finish up my internship online. And then after my internship, I just recently got an offer to work with the Washington Conservation Corps in the SeaTac area with an environmental justice crew, so I'm really excited about that. And then, yeah, I just wanted to thank CRC, C-Stream, Randy, Bart, all the interns here, everybody involved in making this internship a reality, including my parents who drove all the way with me 3,000 miles. And then, of course, the Virginia Institute of Marine Science, my mentor, Dr. Molly Mitchell, her grad student, Emma Dodsworth, who was my office buddy for a little bit, and then everyone who was generous enough to speak with me and so I could learn more about their work. But, yeah, so if anyone has questions, I'm here. Yes.
I always have a question, I'm sorry. I'm always fascinating. When that story map format came out, there was like an explosion of story maps. And when, we're talking a lot about, we produce these outreach materials, but we don't really know, if they lead to action, how transformative they are. So what's your thought about story maps? And are you gonna talk to people about whether that form of communication, how is it like the most effective way we can get somebody engaged in thinking through something?
Okay, so the question was for people online, what are my thoughts on story maps and whether or not that's the best way for engagement? I have personally really enjoyed story maps just because I feel like they're sort of like a website in a way, but they're just like, there's a lot you can do with them. You can add links, you can add videos. So there's a lot you can do with it. I think the issue is getting people to know that they exist and making sure that they're available in areas where people can access them. So I definitely think that's something that should be, implemented into my project moving forward, is making sure that people know about it, since that's a big part. I do think that they're a really great tool for spreading information, though. Any other questions? Yeah.
Sorry, I noticed one of the case studies that you had up there for a second, and maybe you could speak to it a little bit more. But the schools and hazardous, or
yeah,
right, and I'm like utility, like putting data right next to each other. It's like you have school sites, you have hazardous waste sites.
Yeah.
Are they close? And like, what kind of things did you? I don't know how close you can look at that, but like.
So for the case studies, I actually was able to look pretty closely. After doing the tutorial part of it, I was able to like look at specific areas and point that out for people, so that way they could see how they could use the tool. So for example, here I added the sea level rise layer and then looked at what areas would be affected by that. So yeah, I think you can definitely use the tool to like look and see like, are there populations that are more vulnerable and have hazardous material sites close to them? So yeah. Anything else?
Let's give your parents a round of applause.
Thank you.
Thank you. Appreciate it. Good job. All right, next coming up, we have Henry. I'm sorry, Diego. Sorry, I looked right at you and said Henry. My bad. You need any notes pulled up?
Yes.
Okay. Do you know how to do that?
Yeah.
Right, cool. Let me just. You want to move it over there when you get ready. If you know how to do that. Just drag it from there.
Yes. Okay. Yes. Okay. So, good afternoon, everyone. My name is Diego Henriquez, and I intern with the Chesapeake Bay program. So, this summer, I had the amazing opportunity to work with my mentors, Lorenzo and Chusance, on a project regarding the management of invasive knotweed at Rock Creek Park in Washington, D.C. So, but first, some information about me. I'm a rising sophomore at the University of Maryland, majoring in environmental science and technology with a minor in data science. The reason why I was interested in this internship was because, well, first of all, is it support of first-generation college students, which I am one of them, but also because of how it aligned with my academic and professional interests and what I hope to, potentially do when I graduate from university in 3 or so years. As to what I'll be doing when that happens, I'm not entirely sure. I've thought about going to grad school since it seems that grad school is kind of a requirement for lots of the jobs I'm interested in. But also, I would like to be an ecosystem scientist since I had the opportunity this last semester to take a class in wetland restoration, and it really resonated with me. So that was kind of what inspired me to pursue this internship. So what I was going to do with this project is that I was tasked with investigating and quantifying the potential costs and benefits of implementing knotweed management for practitioners in riparian forest buffers. Specifically, I did work at the Chesapeake Bay Program Office in Annapolis. So what this project was aiming to do was to see how invasives, and I'm going to call them RFBs from here on out, present a threat to sediment pollution goals, and how the CBP is interested in emphasizing invasive species management going forward. So the invasive species that I investigated this summer is called knotweed. Scientifically, its name is Rhaeneutra japonica. It was introduced to the North American continent in the late 1800s as an invasive species from East Asia. What made it of particular interest to us was its impact on riparian forest buffers and its contribution to sediment pollution. I was tasked with investigating and quantifying the potential costs and benefits of implementing knotweed management for our practitioners and RFBs. So to achieve my aims of my investigation, multiple methods were used to gain an understanding of knotweed management. First and foremost, I did a literature review to find studies and quantify the erosive effects of knotweed. After reading them, I contacted the authors of those studies and asked if they were aware of further literature or other experts that had information on sediment erosion and costs of management. Using the same method, I contacted people from extension offices at multiple universities and other institutions to gather information on cost estimates for knotweed management. All this information gathering helped prepare me for my fieldwork, which I did from like late May to June. Yeah. The site chosen for that examination was at Rock Creek. This is due to its travel distance from where I live, about 20 minutes, the availability of walkable trails along Rock Creek, and prior knowledge of knotweed in the park. The creek was visually mapped by examining both sides of the creek, marking down that information in ArcGIS field maps on my app on my phone, and then transferring that data into ArcGIS Pro for further analysis. The literature review and contenting experts created an image of how knotweed interacts with the environment. It increases stream bank erosion due to its ability to choke out native species, become a monoculture, and then die off en masse in winter, leaving riverbanks disproportionately exposed to erosive forces. One study found that stream banks with knotweed experienced 3 more centimeters of stream bank erosion. Knotweed was also found to cause significant decreases in biodiversity and total number of plant species in riparian areas. These are all due to knotweed's competitive advantages over native vegetation. However, what makes knotweed particularly tricky to control is its rhizome rooting system. Knotweed spreads by having a weak root system. This creates a weak stream bank, and when there are flooding events, the stream bank is likely to erode, contributing to sediment pollution and spreading rhizome fragments further downstream. This all compounds with how the current extent of knotweed within the Chesapeake Bay watershed is expected to expand with climate change. A warmer climate expands its historical range, presenting various challenges in controlling knotweed in areas where it was not historically present before. All this research culminated in this map. I know it's a bit hard to see, but we'll go through some more zoomed in images for more detail. This map represents the spread of knotweed throughout Rock Creek Park. Those little dots you see are where I found there to be knotweed. Rock Creek is 5 miles long. That's 10 miles of stream bank. 3.66 miles of that stream bank had knotweed present. That means that 34% of Rock Creek's stream banks has knotweed. Furthermore, more than 261,000 square feet of stream bank is infested with knotweed. That's 6 acres of land. So this is knotweed in Upper Rock Creek Park. As you can see, it's pretty sparse. This is knotweed presence in Central Rock Creek Park. It's starting to become denser as we go further downstream. Finally, this is knotweed present in Lower Rock Creek Park. As I mentioned before in my literature review, you can see how knotweed becomes more established the further I went downstream. Combining the information I gathered through my literature review and conversations with experts and the data I got from examining Rock Creek, I determined that it would cost a little more than $20,000 to treat the knotweed in the close to 18,000 feet of Rock Creek in Rock Creek Park with herbicidal treatment. Using an herbicide like glyphosate, one would yield a reduction of about 13 million pounds of sediment from entering the Potomac River and thus the Chesapeake Bay. For every dollar spent on knotweed management, that would be a reduction of 653 pounds per dollar. And while herbicide treatment is not the only method for knotweed management, for the purposes of my investigation, other methods were not included in my calculations. However, as with all studies, there were multiple limitations I had to confront. Determining the benefits of knotweed removal was difficult due to the lack of robust scientific literature regarding the erosive effects of the invasive and the variability of natural processes. This caused an issue in gathering concrete numbers as to how much knotweed removal would reduce sediment pollution. Furthermore, my fieldwork was limited by the tool I had used to initially visually map Rock Creek. ArcGIS Field Maps, while a useful tool, is not a dedicated GPS device. It was on my phone. It had an accuracy of about 5 to 10 meters and would regularly lose collection when I got to the more rural parts of Rock Creek. That's the portion I highlight. Oh, no, wait. I also had an issue accessing about 500 meters of Rock Creek due to difficult terrain. That's the portion I highlighted right there. It was too hilly. I couldn't really see the stream itself. Lastly, the soil estimates I got from the studies were taken across from different time frames, ranging from 7 to 12 months. My calculations were done assuming soil loss rates occurred over a year to allow for simpler analysis. Nonetheless, my results show that herbicidal treatment is a promising method for sediment control, not just within Rock Creek, but also throughout the Chesapeake Bay watershed. Given that knotweed disproportionately contributes to stream bank erosion, threatening the sediment pollution goals set for the Chesapeake Bay watershed, potential actions to reduce this are a ripe area of study. It is not clear what the full extent of knotweed is within the Chesapeake Bay watershed, or what the full returns for knotweed management would be, but there are massive potential benefits to mapping the watershed for knotweed, finding it, and controlling it. Altogether, this summer taught me to analyze the world through a systemic lens, which is why, I apparently, like everybody, thought that my major competency was systems thinking. Systems thinking is vital when it comes to understanding the conditions the Chesapeake Bay stands in presently. Invasive species are not bound by borders nor laws. Knotweed, in particular, spreads from the headwaters of a river to its mouth, jumping from waterway to waterway by creeping along roads and culverts. It doesn't start nor end in Rock Creek Park. In fact, Rock Creek extends about 30 more miles into Maryland. Controlling knotweed at Rock Creek Park, while significantly beneficial, does not fundamentally solve the problem. Knotweed is a Chesapeake Bay watershed-wide issue, and to tackle such a large task, there needs to be a unified systemic response. Speaking with the Chesapeake Bay Forest Work Group, I saw how the lack of funding and attention from the greater program was stifling invasive species management. Fortunately, as I'm sure most of us are aware, the Beyond 2025 draft report is open to public comment. This opportunity gives us the chance to emphasize an integrated watershed scale approach, advocate for watershed scale legislation, and dedicate all available resources towards making our bay healthy. I just wanted to say thank you to my mentors, big thanks to Lorenzo and Shutans. They guided me through this entire process and helped make this incredibly memorable experience. I wouldn't have been able to do this without you guys. These are pictures I took throughout the summer. The one over there is me standing next to knotweed. You can see how tall it is. That one right there is when I went to a conference for Thriving Ag. That's me just doing work in the office. That's me when I had the opportunity to go to, I think it was the National Mall. We went to go look for beetles. And then there was when I did a tour on the Anacostia. And then there's me doing my field work right there, standing next to knotweed. Yeah.
So I know you said that the engineers were primarily to like assess management costs, but I was wondering if in your field work you were able to notice anything like interesting that you didn't predict in terms of like interactions between knotweed and native species.
So that is a pretty good. The question was like interactions between knotweed and the environment I noticed while I was doing field work. So what I noticed while I was actually doing it is that there are not many species that predate on knotweed to begin with, since it is an invasive. But there were instances where I would find that something had eaten the knotweed. I'm not entirely sure what it was, but it is showing that there's something here, like in the Rock Creek Park, that is predating upon the plant, but it's not enough to actually control it. As you can see, that's just one stand of knotweed. And there were multiple times I was going throughout the entire park that there would be entire portions of the creek with knotweed by the stream bank. Yeah. You had a question?
I also had another question about like the cost benefit analysis. So when you're looking at the costs of the cost and benefit of like using herbicide, do you also kind of factor in the costs and benefits of what would replace that, like the cost of putting in native plants and the benefits that would have? Like, is that next step after getting rid of the knotweed? Is that also factored into that?
No. So for this study, as you said, what I focused on was simply the benefits of getting rid of controlling the knotweed and seeing how much sediment that would reduce. I am not entirely sure as to what the benefits of allowing the native species back into it, since the thing about what makes knotweed tricky to control is that you can't truly eradicate it now that it's there. And treating those infestations are incredibly difficult. They can take up to 4 to 5 years of treatment, and there has to be constant application of the herbicide, which not just presents an issue with that some people have issues with using herbicides to begin with, since they can have an impact on the environment, not just on the knotweed, but with other plant species around it. So that could be a pretty interesting future project, though, to see the benefits of allowing, because ultimately that is the goal by controlling knotweed, would be to allow native vegetation to retake that environment back from the invasive.
All right, thanks. We do have a discussion. We have about 2 minutes. You want to say who you are today? Sarah. Come on, sorry. Come on. You gotta stay up here because the mic is up there. What's your spot?
Yeah. Hi, everybody. I'm up here because I told Randy earlier that I was a C-Stream intern, and I think 2019. Since then, I was also in NERTO in 2020 during COVID, but now I work at the Cooperative Oxford Lab, and that was where both my internships were. Working with Jason Spires, doing oyster restoration, and now I'm there not after finishing my PhD. I'm still in my final year of my PhD, but accepted a position early. But I'm here today to support all of the other interns from COL.
All right, thank you. So yeah, just wanted to throw that in there because that's very important to see the full cycle of interns in this program, and show where they're doing now, and to be working where she had that beginning start is says a lot. So keep going. All right, next up we have Shona. Yeah, sorry. I was looking for the slides.
Maybe just as Sean's getting ready to, just like here, not play out anymore. I'm not doing that.
Do you need
Just,
you know how to pull them up?
no, but like in terms of like if you're interested in working in this area in this region, right? There are kind of pathways that exist to be able to support people. We talked about this before, but like Sarah mentioned, like C-Stream is a good while you're an undergraduate or recent graduate thing to get into. Their NCBO programs are great for graduate students. If you're to have opportunity for your graduate students, especially if it's in the funded program. And then CRC's staff work program is sort of the next level, and then from there, other positions. So there's like, I guess the whole point is like part of the program existing is to help people access career opportunities within the big program. And we really like seriously. I appreciate you coming up.
Just press the space bar, or these ones.
Thank you. Yeah, you're like number 2. Great. But it's just like that the pathway is, I mean, for people that are in the program right now, just like the pathway is real. And so it's a cool opportunity for people's brains maybe, or just knowing that it has transitioned people into a federal career is an important piece for all of the people that are now working for Choose Clean Waters. All right, sorry, Sean.
You're fine. Awesome. So, good afternoon. My name is LaShawna Perry, and welcome to Toadfish Tunes, tracking mating calls on the Oxford Reef using passive acoustics. I worked this summer with my mentor, Cecily Stepp, over at the Naval Academy with Soundscapes. All right, so just who am I? You're looking at a rising sophomore from the illustrious Bowie State University studying for a bachelor's in computer science with a focus in cybersecurity. I'm a C-Stream fellow and I'm working with the Naval Academy, like I said, and my background, I was born up here, but I was raised in Jamaica where I learned a love of nature. And as you can see, that photo over there is Kingston, our capital. And one of the best things I remember about my time there is when I saw the Blue Lagoon. I'm not sure if you all know what that is. It's glowing water, basically. I'm not sure how to describe it. I'm sure there's a lot of bio stuff. Sorry. Okay, so basically we were working at the Oxford site and we were listening to toadfish using a hydrophone to assess the health of the reef. The hypothesis that we had was that each 2-hour sampling period would be different. And I based this off of some literature that I read before this. One of the key ones that you will see mentioned again in this slideshow is investigating the utility of echoacoustic metrics in marine soundscapes. So, in general, oyster reefs in Maryland, including those in the Chesapeake Bay and its tributaries, like in the one in Severn River, have seen significant restoration activities due to historical declines from things like overharvesting, diseases, and habitat degradation. So recent efforts have been aimed at enhancing oyster populations due to these factors. And oyster reefs are crucial to the ecosystem as they provide habitat for various marine species. They filter water and they protect shorelines from erosion. And Oyster reefs are especially important to the oyster toadfish because they provide protection from predators. They're suitable sites for laying their eggs and abundant food resources within the estuarine ecosystem. I mean, they share a name. So the study site, as I said, was at the Oxford lab. And it was between the Oxford lab and the Naval Academy where there was the office that we would work at, but the site that we're looking at today is the Oxford lab, where they had things like environmental monitoring equipment there as well, analytical instruments, and other things like aquatic holding facilities. Okay. So how we went about this is that we would go over to where the hydrophone was stationed. Sometimes we'd get some help from one of the cadets, I believe. And then we would ask them to pull up the hydrophone as it was attached to a cinder block and was really heavy. And then we would detach it from there, clean off all the biofoul, and open it up. And then over here, you'll see the guts. We would, if the batteries need changing, we change those. We'd configure it so that every 2 hours, it would take about 2 minutes or 120 seconds of data. And then we would use an application called Raven to manually assess the data to see how many times we would hear the toadfish's call. And then we put that in a spreadsheet. So we had around 456 sound files. And here you could see what what Raven looked like, what I would see whenever I'd go through all those 400 sound files. Would you like to hear the toadfish?
Yes. What do they sound like?
I'm not sure how to do this. Okay.
You might have to move the cursor all the way.
Oh, interesting.
Oh, I'm going to crank up the speaker too.
Yeah. That's it.
That's what it sounds like?
Yeah.
One more time.
It's a small little horn sound. You guys hearing anything? Okay. So along with the toadfish noises, we'd have to sift through other audio, like from the boats, waves. There were things like scratching. And at one point, we did manage to hear a croaker, which was pretty cool. Ooh. Yeah. So these are basically how many sounds over the 120 seconds that we would hear per day. So they started around very late April, and then it continued on until the middle of May. And then over here, these are the mean by the time of day that we would analyze. So every 2 hour period, these are them in military. So the A and C's are basically, they're basically telling you which ones did not have a significant difference statistically. So the B's, all of those are grouped together. They didn't have a significant difference from each other. And because of each of these being 2 hour sampling periods, so we have 12 sets of data, the only way that we could say that any of the information was independent from each other was if they were 12 hours apart. And so This brings us back to the literature that I mentioned before. It focused on the Harris Creek and the toadfish calls that happened there. So they generally start earlier at the southern latitudes and progressively later on as we move up north. So for example, late March in the May River, South Carolina, early April in the Pamlico Sound, North Carolina. And then when we get to the Chesapeake Bay, it's early May and then mid-May in the Eel Pond in Massachusetts. And then Harris Creek obviously followed those. So the daily patterns, when it comes to the daily patterns, toadfish, although toadfish are known to call throughout the day and night, they typically drop in call rates just before sunrise and peak around dusk. This pattern has been observed in multiple sites, including those in West Florida Shelf and the Florida Keys. In Harris Creek, we see a similar pattern was observed and calls decreasing in the early morning from 6 to 9 and peaking around dusk. And then you can see the same thing happening in the Oxford Creek. Okay. So for restored reefs, usually you'll see higher average call rates, 80 to 110 calls per minute. And then because of that, it would tell you that there's a higher oyster density as the toadfish are attracted to these reefs. So more oyster density there, you'll have more toadfish. And then you'll see the opposite happening in unrestored reefs. So there's a lower average call rate, and then you'll see there's a much lower oyster density. And in the Oxford reefs, it follows this. And the lower oyster density, we couldn't get a specific number for it, but we estimate somewhere around the same to the unrestored reefs. As back in 2023, there were times when they were, I believe, putting adolescent oysters into the reef over at the Oxford, but that information wasn't on the website for this year. Okay. So key findings. The Oxford Reef showed very low toadfish call rates resembling unrestored reefs, like I said. There is a noticeable difference in call rates in reef health when comparing the Oxford Reef to the restored reefs of the Harris Creek. So now that we know that toadfish are more reliable in assessing the reef health when monitoring them through the use of hydrophones, we can say that we should continue acoustic monitoring to better understand the reef health and the effectiveness of restoration efforts. But we should also know that some automation might be needed to get more accurate data. As you might have heard with the sound system over there, it tends to be very low when you're listening out for the toadfish. So human ears might not be able to pick up on it as well as machine. Okay. And then, there's also noise interferences like the boats, the scratching, and then the gaps in data and limitations when we looked over at the oyster reef or the Oxford Reef. Okay. Other experiences, I would say my favorite experience of working on this internship was the time that I got to interact with my mentor, as just the amount of conversation that we would manage to have on the oyster toadfish, different species, and somehow jump into futuristic development of the spinal system somehow. One of my other favorite things that I got to do for this summer was when we went over to the Chesapeake Bay Community Research Symposium, and I got to see the other things that people were working on, and I got to hear different presentations that students were having. And then I would say that while this was happening, I still got to interact with other mentors. One of them requested a day in the life of a C-Stream intern video. So I created this for them. And then another one, they got me to do this Microsoft Shadow Day thing. And so I got to see, while I was doing C-Stream, I continued to work on the computer science aspect of my life. And so because of that, I would say that I'm still learning. I'm still going through all these experiences, so I'm not 100% sure what I want to do with my future. But I do know that I do want to include working outside and utilizing my skills in computer science to help the environment. And then for systems thinking, so analyzing toadfish calls as a measure of reef health integrates biological, ecological, and environmental systems. Toadfish populations indicate the health of oyster reefs, and that contributes to other greater marine biodiversity and ecosystem services, because those services affect, along with human activity, affect the reef health and toadfish populations. And if we can get that data to monitor the health and then implement protective measures based on that data to preserve oyster reefs and associated marine life. This is not going great. This is not going great.
We're pretty much out of time, so this
Yeah.
Thank you. Thank you. It's good.
Yeah.
So quick question, did you get to interact with toadfish, like living ones out there?
I did not. I wish I did. I did not. I got to see one through video, and that was basically it.
Yeah.
Yeah.
It's cool that they're all over though.
Yeah.
Or something. Other like maybe one question? All right, cool.
You're welcome.
Got it. You did it.
Shout out to Jen, especially for helping us with all of the technical difficulties that we have.
You already done Naval Academy?
Yes,
Yeah.
and especially.
Do you need notes pulled up?
No, I have them on my script. I apologize to the people on Zoom if I bust your eardrums out. Can everyone hear me in the back? If you cannot, please tell me. Lovely. Okay. Good afternoon, everyone. I know we've had a long day of listening presentations, but thank you for being patient. My name is Colleen Watering, and today I will be talking to you about management practices for the city of Norfolk. A little bit about myself. I'm currently attending Sweetbriar College and am on track to receive my bachelor's degree in environmental science come the spring of next year. Speaking of Sweetbriar, I have two pictures about my life as an environmental science student on campus. So that picture that you see on the left is grapes that I collected in our vineyards at Sweetbriar during my senior seminar class. And to the right, you see the sunset over our very own greenhouse that provides local fruits and vegetables to the outside community and our faculty and staff, as well as our dining hall. I have always wanted to know more about the Chesapeake Bay, just because while I didn't live in the area, I've always grown up knowing something about the way that it works or learning about it in the classroom. Excuse me, sorry. Through Sweetbriar, I've also had hands-on experience analyzing how pollution can affect bodies of water through invasive species, algae blooms, and overpopulation. When looking at projects for applying for this internship, I had just finished a 12-week mapping class where I had learned how to analyze data, make a detailed map, interact with story maps, interact with ArcGIS itself. So I had really enjoyed that class, so I looked for that when I was looking at internships. Through this internship, I have learned that I would love to continue my work in the federal government and possibly a potential staffing program if I can find one upon graduation. I've not really yet honed on one interest for grad school, but I do know that I would love to go back and further my degree one day in the future. Now, looking into my summer, I studied under Professor Wang, looking into the Norfolk area part of the Chesapeake Bay in partnership with Old Dominion University. With this, I was instructed to make a map of the best management practices centered in the Norfolk area in order to inform the community about how better to manage stormwater flooding. This is important to the Chesapeake region due to the increased pollution runoff flooding causes in the bay and surrounding watersheds. With this map, the hope is to contribute to large-scale and long-term natural resource management and policy development. At the start of my project, I was briefly aware of management practices, also known as BMPs, which, if you are unfamiliar with those, these are devices and actions to help improve or prevent urban runoff and stormwater. To start my research, I looked over all 18 approved BMPs for the state of Virginia. Through analyzing these BMPs, I learned that they're all based on elevation, groundwater, and the infrastructure surrounding it. To look at these BMPs in relation to the city of Norfolk, I was instructed to make a map in ArcGIS, which we've learned a lot about today, but I'll briefly indicate what the program is. So it's a comprehensive geospatial platform for professionals and organizations to use. To accomplish this, I needed 3 maps, which Professor Wang provided me. Those were soil layers, elevation, and groundwater. On to my results. This is what I achieved. So on the left, you see the city of Norfolk outlined, and this was just to show the area of interest. And then on the right, you see the layer that outlines, which is probably very hard to see from all the way in the back, but outlined in little gray is all the cities and counties in the Norfolk area. And this is the layer that gave me all of the soil types and the infrastructure of the areas. The next layer that I added on, which is on the left in the orange, is all of the bodies of water surrounding the Norfolk area. We needed to look at this due to the fact that many practices are perfect to be near water and some do not need to be near water at all due to the pollution that they manage. On the right, we added the groundwater layer in green because some practices do mention groundwater very loosely, defining it as the coastal plain region, and others do not. So we decided to add that layer as well. The last layer to be added is shown on the left. I had it on the right as my notes, sorry. And that is under all the previous layers is the elevation layer. We needed to look at this just because some BMPs are perfect for higher slopes and they need those higher slopes, and some work well in the lower slope areas due to how they are. And on the right, I have zoomed into one of the pop-ups on the map that displays the soil type, the topographic, and the BMP that's perfect for the area. There are a few things that I think can be expanded upon during future research. That is groundwater implementation, and more management practices. Excuse me. Many of the BMP's documents do not mention quantitative data for groundwater. In order for these practices to work their best, they mention the coastal plain region. Well, we know as scientists what that means. Many people who are using these are farms, and they may or may not know what that means. So adding the quantitative data would better help people understand what management practice will work best in their area. And there are only 18 approved BMPs for the use in the state of Virginia. So I just think as more BMPs are worked and analyzed through the EPA, that we can look into adding more to our list of approved practices. Over the summer, we've all heard about the competencies that we looked at, and those were ethical reasoning, multicultural awareness, systems thinking, and civil responsibility. In my project, I felt that civic responsibility fit the best. Civic responsibility is a perceived duty to make a difference in the civic life of our communities and to develop the combination of knowledge, skills, values, and motivations to make a difference. In my project, we were helping the city/county runners better understand the floodings in their town, and this helps a public issue as well as helping them make better informed decisions for their town. This competency helped me understand how to define a city's problem as it affects the whole of the community, such as its impact on lower income communities and cultural barriers that may come up. Lastly, just a thank you to the Consortium for this amazing opportunity, Professor Wang for being my mentor, Randy for helping in all his planning, and everyone's hands that go into making the program flow. Thank you. Does anyone have any questions? Yeah.
So, did you get to the point where you felt pretty confident that if you zoomed in on an area, you could really somebody could make a much better decision about what BMP would work in that context?
I think so. There is, when I was doing my basic research, there are efforts in the Norfolk community to implement these management practices, but my hope was to give these to the community development so that they're not going in completely blind. My hope is that they can zoom in on this and see that, oh, it's not just what can fit and what we can improve on that's the old infrastructure. We actually need to look at all these other things. And I hope that people can look at it and know.
Do you have enough information on the BMPs themselves?
Yes. I went through documents from, oh goodness, I do not remember the source that those came from, but they were like 20 plus page long documents that I went through and had to read and pick out that, oh, this works best in soil type C. It works okay in soil type A and B, but it's best for C and D soil types. And it also had, oh, it needs to not be near X, Y, and Z infrastructures due to all of the construction it takes, or there were just massive amounts of information in those documents that I had to sort through.
Wow. And you managed to, would you give sort of a ranking of the BMPs, or was it like yes, no for this location?
I more did a yes, no, just because I tried to do a ranking, but I couldn't do the best ranking to the best of my ability due to never seeing things in person. Just because you never know how crowded areas can be, or you look at the infrastructure and you're like, ooh, that says urbanization, or sometimes it was just a town name. So I kind of had to use what knowledge I did know about the area for some of them, and what knowledge I did know about how much it took and the specs that I looked at, because those documents that I even read included the specs and their upkeep and things like that. So I just had to look at that as well and pick to the best of my knowledge. Anyone else? Yes.
So what keeps on coming to my mind on this too is like, so it's neat that the tool can identify appropriate PMPs for any location. Next level is like the cost.
Yes.
Implementation and like the benefit for like how much sediment is controlled,
Yep.
stormwater keeps somehow. So is that a next level thing, or did you look at that at all? Or do you have any guidance for people that might be following up on you to add, like, if you're gonna put in this PMP, it's probably gonna cost you.
It is very, in those documents, it's also very laid out how much that will cost. And like, hold on, sorry, I think it's on my little thingamadoo. The vegetated roof, for example, they had an entire page and a half, I want to say, of plants that would work and what those plants did to suck out the pollutants that were coming in. And so I think that it is very well laid out in those documents for someone to come in and do what's next, if that makes sense. Yeah, I think so. It would be very easy to do.
Thank you. So that pretty much concludes our show here today. One thing I do want to do before we leave is turn this whole area into a little photo booth. So if anybody's just here with their parents, if you want to come up, I'll take a picture for you all. If you're here with your brother or anyone else, or if you want to take a picture with your mentor who's here, you and Henry, Diego, keep calling him. But with just some last minute things. But first, I just want to say definitely thank you all for give yourselves a round of applause.